Vanessa. I hope you get home safely. Be careful. Get home safe. By the way, Smiling Retsan, I like your nickname. You have a really nice nickname. And what are you going to cook? I'm kind of curious. What are you going to cook? Ooh, okay. So, in previous stream on Friday, we had some issue. For example, thank you kindly. I want to spread joy and I'm making spaghetti with some sauce to it. Wanted to make the national dish due to the new monarchs, but it was sold out. Oh, monarchs. If may I ask, where are you living? There is not a lot of countries with monarchs still. It's still like British, Denmark. Right, Denmark. We got new king today. Oh my god, yeah. It's like United Kingdom, Denmark. I think it's Norway. Norway has princess and such, right? If I'm not wrong. Hi Faraz, welcome back to the stream. Or welcome to the stream. I hope you're having an amazing day. Good. Well, I hope the spaghetti sounds amazing. I hope that they will come out good. I hope they will come out good. Boom. And welcome to the stream for us. I hope you're having a good day. So, in previous stream at the beginning, we had issues. I love spaghetti. I love spaghetti too. I love pasta overall. Pasta is so good. Like, pasta good. Yeah, exactly. I love pasta. I hope the piano is okay in the background. I feel like I really love piano, so I like it. I like to listen to it when I'm programming. Because there are no voices, and usually voices distract me. But if it's just instrument, I can kinda handle it. If it's like one instrument, and piano is really amazing for that kind of thing. Piano is very relaxing and it helps with thinking. Thank you. But the issue, previous stream, actually, because I don't usually work on this computer, right? I'm not programming on this computer. So I just moved my config files from my laptop and there were issues. For example, we were missing emojis here in my prompt. So instead of the crab emoji, I had just a rectangle, which usually means it's missing. The thing is, I thought this, I can zoom it. I have to zoom it again. I always forget I have to zoom it for stream. Boom. How big? I don't know. I will zoom it like this now. So basically, this emoji wasn't there. And I figured out why. Obviously, I was missing the font. I was missing the font for the emoji. But the thing is, oh my god, FC list, yeah. We can check every installed font if it has this Unicode character, which is this emoji. The crab is 1F980. So when we check for it, it's only in Notocolor emoji, which is from Google. But I was thinking the emoji will be in nerd font, right? Because if we check my fonts, how do I check it? Like this, TTF. When we check my fonts install, these are my install fonts. I'm using Firecode, and I'm using Firecode Nerd, and I thought the Nerd fonts have the emoji actually, and they didn't. So I just checked for it in my installed fonts, and I didn't find it. So that's basically it. Then I went, oh my god, I have so many tabs from previous stream. But basically, I went to Google, I wrote font with 1F980, and there is actually a website called File Format Info. When we open that, it tells you, basically it's crap with this Unicode ID, and the fonts that support it, at least some of them, are these. And as you can see, there is not a color emoji, which is what I'm using right now. So, yeah. Also, the last resort symbol has crap and such. So yeah, that's good to know. This Unicode character is not supported in a lot of fonts. I'm actually surprised. I'm actually very surprised this isn't supported in a lot of fonts. Because I feel like the crap emoji is so common these days now. Especially with the Rust being getting so popular. It's kind of weird that it's not in nerd fonts, right? I don't know if that's just me, but it's weird. It's weird. But that's it. That's basically what I did. So I downloaded the font. Crab Raver. Yeah, crabs are everywhere. Why nerd fonts don't have it? For example, if we go to nerd fonts website, right? Here. And we check cheat sheet. And now we write down our... we write down the Unicode code for the crab emoji. And by the way, welcome to the stream, Goldmine444. I hope you'll enjoy the stream, and I hope you're having an amazing day. But yeah, when I click enter, it's not there. It's not there. Nerd font never had crab emoji. I don't know why. Oh, thank you for the follow, Goldmine. Thank you for the follow, and welcome to my plushie collection. But yeah, nerd fonts really don't have crap emoji. It's some different emote. It's 1F. I was so surprised by it. I don't know if I should be, but that's why we were missing the crap, that's it. That's basically the issue. And another issue was... basically, with the shaders, maybe you need the Unicode of... I don't think I do. Let me check. No. Nerd fonts never supported it. For example, if I use only F980, which is different emote, it even tells you this emote was removed in nerd font from version 3. It tells you it's removed here. But it's not the one we want, it's this one. And it was never in nerd fonts. And crap emote never was in these fonts. So that's interesting to know, I guess. Yeah. The font that has it that I use is the Notocolor emoji. This is like one of the only ones that have it. These fonts are the only ones that have crap emoji. Look at this. And this is how they look. This is apparently crap emoji. I don't know what. Color emoji doesn't show, but that's the one I use. Then there is the emoji regular, which is the same from Google font, but just without color. It's like monochrome. Then we have the Symbola, which is kind of weird crap actually. I don't like that one. It's too small in this crap. And then you have the pixelated one. So yeah, I'm using just Notocolor emoji. That's it. That was the issue. I was just missing font. So I figured that out. But the second issue I had in previous stream was with the shader. I didn't have syntax highlighting for my shaders. When we check it now, it works. We have syntax highlighting for my shader files. So, and we have even the language server. So if I write buffer, it automatically shows the buffer has data field, and we can, yeah, basically have some auto completion for the shaders and even syntax highlighting, which is very cool. And we were missing that previous time. It was basically, I can show you what the issue was in my NeoVim config. When you go into plugins, Vim Jesus here. So I added this thing, FT, but before it, I confused it, right? FT is like file type. It's not actually extension. It's not extension of the file. It's file type. So I added only frac, vert, and comp. So it didn't work, right? Because the Vim GLSL sets the files to this file type, which is GLSL. So I could remove it and it works too, and probably better. So we can just remove it even. And when we now go to my shader, boom, still works. Let me update my plugins. Now get okay, boom. Good. that were the issues we had in previous stream. They are fixed. Yeah, I'm not using this setup usually for programming, but I moved my configs here, so I could actually use it. So, we ended here. We were reading the Vulkan RS. We were reading the Vulkan RS tutorial for Vulkan, and we were learning. In previous stream, we learned how to initialize Vulkan, how to initialize buffers, how to do compute pipeline. And we learned about, where is it? Here? It's actually a very good link. We learned about the Q families. So Q family 0 is for the graphics pipeline, Q family 2 is for the compute pipeline, for Q family 3, that's the decoding of the videos and encoding, even though, as we can see, these are facts. So this is the graphics bit, only the first one, compute bit is the first one and this one, but this is the main compute family. And then we have the video decode, which is the last family. I should probably go make spaghetti now. I'm being hungry, son. I hope we will make good spaghetti. What kind of spaghetti? Long spaghetti. I hope I don't get entangled by it. I hope too. I hope you don't get entangled. And I hope you will enjoy your spaghetti. Thank you. I will know my spaghetti when it's done. Good. Good. And then we also learned about the memory chips. Bye, thank you. Thank you for dropping in my stream. And if you want to see more of it, you can give me follow or such. Let me hydrate quickly. We are looking at the information about the GTX 1080 Ti because it's the GPU I have. So I want to see the information about my GPU so I can know more about it, I guess, or I don't know how to describe it. I just choose that I use. Then we look at the memory chips and we figure out that some memory chips have host visible and some don't have. So in the some memory chips, the CPU of our computer can actually look into, which is interesting, and you choose that by memory type filter. So if we choose prefer local device, it will use the local video memory on the graphics card. And if we choose, we want to be able to see it from the CPU, from the computer. We have to add where is it? I forgot how it's named. It's basically it's this bit. It's basically host visible, but it's named differently here. Alright, when we check, it's called host sequential write. It's this. It's this one. Memory type filter host sequential. And that's it. That will allow us, the CPU, to see it. It will make sure, it will choose memory that the CPU can see. When I find more of it. Yeah. here memory type filter device, which is the video memory on the GPU, and host sequential, which is host visible. Good. I should maybe update it actually. Let's do some update of the dependencies quickly and build it. I hope the music isn't too loud. It's quite loud, I don't know. But it's compiling. So that's basically what we learned. That's everything we learned. We learned about the shaders, we learned about that stuff. We know that there is a lot of shader languages that we can use to compile the shaders into Sphere V, which then can be sent to the GPUs. And they have their own another like transpilation process, so they understand it. But Sphere V is like the common binary representation of the compiled shaders. We had the blog review of shader language. It's this one. Yeah, like HLSL, GLSL, which is the good old one. Then we have MSL, we have VGSL, and basically all these you can use any you want, basically. Some are nicer, some are more modern. For example, the GLSL is very old, right? It's very old, so I mean it looks a lot like C, so it's not bad. It looks a lot like C, so it's not really bad. It seems too hard for Panda's brain. Welcome to the stream, Panda. Hope you're having a good day. How are you? How are you? How are you doing? I hope you're doing better. But yeah, welcome to the stream. And different shader languages have better like semantics. Sick. Oh, I hope you feel better soon, Panda. I hope you feel better soon. Take care of yourself. Drink a lot, especially yeah. You have to drink very, very much. But yeah, that's basically what we did in previous stream. That was the issues we had, and I showed you. Now let's clean up the code a little bit, because the tutorial made us do more stuff than we need to for the compute pipeline. So I want to actually clean it a little bit. Oh, which should be like from everything from here. It should be to a what is buffer here, my stack buffer contents, procoder right here. I'm not professional because I don't have work, right? I'm unemployed, so technically I'm not professional, because to be professional I usually have to be employed, right? If I'm not wrong, maybe I'm wrong, I don't know. But yeah, let's delete these. Let's delete this stuff, and that should be completely okay. We just have to import some stuff because I was importing the stuff as they said it in the same order, in the same place, and not at the top of my file. So we just import them. Boom. Yeah, import GPU feature. Boom. And that's it, and it should work again. Let's check it. When we run cargo run VTuber client, of course it has to compile. I could also use the terminal in here. It could be nicer actually. Oh my god, I cannot type again. And I always forget how to type. But yeah, let's watch this. It will compile the shaders, the Vulkan. Now it's compiling my application. Boom! And it ran on the GPU. We made calculation. We used the compute pipeline with the compute shader, and we calculated Simple stuff. We basically multiplied 65,000 numbers by 12. Yeah. It's okay, I keep forgetting how beautiful you are. I'm not beautiful. I'm not beautiful. I'm not. Yeah, we learn also how to get the shaders in, which is through the Vulkan shaders library. There is a lot of things inside it. You can inline the shader code with source like this, which I don't like. I don't like that. I want the shader code in my own named files. You can specify versions, define different things. Shaders, you can make more of them. Let's read it. With these options, the user can compile several shaders in single macro invocation. Each entry key will be suffix of the generated load function. Load first in this case. Ooh, see? So you can actually compile more shaders in one of the macros, which is interesting. True, you gorgeous, my very boss. I am not gorgeous, panda. I'm not, I'm ugly. But thank you. You're making me blush. Make sure to hydrate, silly. Make sure to hydrate. And I should refill my glass. Second. There is my water. Water, come to me. Ah, I got water. I beg to differ. You plushies. You plushies. They're all so adorable. But yeah, let me refill my glass because I was late and I was taking my pills. I just drank all of it, so I have to refill my glass. Second. Ah. Glass refilled. Let me do hydrates so my throat doesn't die. Mom. But yeah, we learned a lot of stuff actually. And we have to use different allocators. There is so okay. I'm back live. I have no idea what happened. Reconnection successful. Okay. I'm back. Hello everyone. I have no idea what happened. I just got notification my OBS disconnected and I couldn't load anything. Huh. That's a weird one. That's a weird one. Welcome back. Thank you, Goldmine. How long was I offline? And how big delay is there? I feel like now there will be big delay. Let's check it out. Let's check how big of a delay that is. Right. About 2-3 minutes. Oh, I was offline. Okay. Okay, there is not a big delay for me. So if you have big delay, refresh your web page. Like, maybe not even refresh, quit it, close the tab, and open it again. Because Twitch has issues with the buffering and such, so sometimes it can go wrong. Yeah. Thank you for the slap, XLR. Oh, now I got all the messages. Second. Did you got this all yourself? Roro, Ragi, we dying, not that, just heavy sleeping. Oh. What did I call myself? What do you mean, Goldmine? What you mean this? I mean, we were learning from this website. They have code snippets and are explaining how to do the stuff. So I basically read everything. And I try to explain it in my own way, so I would remember it. Because usually when I explain it my way, I don't forget the stuff. So I always read it, I try to explain it in my way, and then we copied the snippet code, and yeah. And we just went by the code. So you could say I did it by myself, but I used the tutorial webpage for the Vulkan. But yeah, now we can continue onto using images, which is chapter 5. And I hope the internet doesn't die again. Still impressive. Thank you. Thank you. If you don't know what this is, this whole project, that's how you learn. Yeah, I feel like explaining is the best way to learn. Actually, explaining is the best way to learn, because if I think about it myself and create my own understanding of it and try to explain my understanding, then I don't forget, right? Which is, yeah. But yeah, this whole project is basically my Twitch integration thingy. So I have my Twitch bot here, right? I have my Twitch bot. That should be in chat, but I think it disconnected. We will see if it works. Let's try it. It actually works. Okay. So it reconnected back. I can show you even, I think. Let's go. Let's SSH into my server. Let's SSH into my server and check. Here. So we can see we can actually see how my internet dropped. Look at this. We can see how my internet dropped. So the internet dropped at 16:20 and 40 seconds. And the internet went back at 22 minutes. So it took like two minutes. Internet was off. Yeah, this is my bot basically. I have multiple parts in my bot. So I have the bot itself. What is this log? It's log of my bot. I'm connected. I SSH into my server, and this is running on my server. So this thing on the left is my I call it just Twitch server. It gathers all the data. Like messages, it gathers follows, donations, it gathers everything like this, right? And then this program, which is running here on the left, can send it to any number of other programs. For example, I have another program here, and this program on the right, which is the Twitch bot, connects to this server. It actually exposes ports. This on the left, the program, the Twitch server mine, exposes ports, and the bot connects to the server, and it receives all the events that are happening and messages. So it connects, it identifies what it is. So it says, for example, it needs to able to send messages or needs to be able to only read them. Do you have that on GitHub? I have it on personal GitLab. It's not public. I have it on my personal GitLab. I use GitLab for my stuff, not GitHub. I don't have good experience with GitHub. Yeah. But that's it. So the thing on the right is just this Twitch bot. I can show you how it connects to the Twitch server. We are using TLS, by the way. We are using TLS because you can have it on multiple computers, and you can, for example, have the Twitch server on one computer, and with the bot you can connect from different computer to the Twitch server through TLS. So, yeah. But basically, we establish connection on specific port. This time it's on localhost because it's running on the same computer. We do TLS handshake. We send in binary format what client we are. For example, we are interactive, or we can be only receiver. Interactive can send messages in chat, which TwitchBot usually needs. So we are interactive. We read the authentication code for Twitch here, because the Twitch server sends it back, so we just read it. We set up different things, like we check if I'm online, we set interval for automatic messages, we set time format, we have some functions to find when my next time for medication is, we have function that finds next time I'm streaming, right? So I'm usually streaming on Friday and Saturday, and yeah, I usually start at 15 in my time zone, but I have 16 here because this is for apologizing on my Discord. So if I'm hour late, my Discord bot will send everyone message in the announcement channel, and it will apologize I didn't go live for me. We have the Discord client here, which is just HTTP thingy, because we are using web. How is it called? Let's find it, I guess. We have bot detection, so if there are bots, my bot is able to detect bots that are, for example, spamming my follower thingies, because there are a lot of follow bots on Twitch that have like not nice names, right? The names are swearing and are being transphobic and homophobic and everything. So my bot is able to detect that stuff and ban them automatically and don't show them on my screen, because when you follow me, there is a notification, and my bot is able to filter that stuff out. So the notification for the bots doesn't show up, or with the swearing, it doesn't show up. But currently I'm using different alerts, right? I'm not using my stuff yet because it doesn't have the rendering. We are working on the rendering right now. But as you can see, we are just checking for a stream, HRT, the message is meant to send. We read the information from the Twitch server that's sending the stuff from TLS stream, and we just deserialize it into my enum that basically has what happened. So it can be event, it can be other stuff. And for example, on event stream online, and it sends this welcome message to the webhook. Yes, it's called Discord webhook. It sends message through webhook in my announcements channel. When stream is offline, it sends into my channel chat, thank you for watching my stream. For channel follow, there is this stuff with the bot, right? That's a little more complicated. We did that in previous stream. I have on my YouTube channel, there are my bots, and you can actually find the bot of me doing this bot thingy. Yeah, how we did this bot thingy for detecting bots. How we used bit flags and yeah, all that stuff. For channel rates, it automatically does shoutouts for people. For different channels I'm modding even. So example, I'm mod for Mizu, so when someone rates Mizu, it gives the people automatic shoutout. And when I receive shoutout, it joins their channel and it says this automatic message, as we can check here. Automatic message, thank you for the shoutout, I'll check you out later if I didn't raid you. This is for messages, so we are handling commands here. There are a lot of commands, as you can see. We have for lurking, we have show lurkers, we have death counting, we have timers, we have a list of commands or what we are doing today, some links. You can send me notification on my laptop. So for example, if you do in chat notify Arisha and for example type hey there QT, it sends notification. It sends notification to my laptop. We can check my server actually for that. Yeah. Here, my Twitch bot said failed to send notification because there is no notifications. Right, I don't have like a desktop running on my server right now. But usually I'm running that on my laptop, so I get notification, and it even says, user princess wants your attention in this channel chat with this message. It's basically just this thing, chatbot. Then we have Twitch client, I don't work on that. That will be just for sending messages, so I don't have to use the web GUI. We have the Twitch server, which is doing all the stuff for receiving messages. Right, where can I show you? So we have, it listens onto the events, it listens onto the chat, it refreshes the tokens, everything, it checks if someone did Ctrl-C on the program so it can actually shut it down properly. Yeah. I'm using async for it. We are using a lot of single producer, multi-receiver or multi-producer, single receivers of stuff, channels, validating tokens, using OAuth queue. But yeah, that's it. And we have actually here in the Twitch shared, which is like a library only. We have the Twitch chat and Twitch events. So this is actually the stuff that's checking for the events. That's registering the subscription for the events and all that stuff, and for chat. Because I made my own IRC parser even. I didn't use some library. I created my own IRC client basically for Twitch with my parse combinators. for parsing all the messages. Yeah, and turning them into types, because I really like types. I don't like things that are just strings. So I'm just taking the strings, the data, and converting them into enums, structures, and such, so it's simple to work with, right? It checks even if I don't have permissions and all that stuff. That's basically everything it does right now. And we are working on the stream overlay and VTuber client, but first it will be only stream overlay. The VTuber stuff will come later. Okay. You have 50 minutes in, I just explained this stuff. But I wanted to explain people. All of it. But yeah. We also in previous stream, we made the notification thingy. So we are notification, how would I call it? System kinda. If we check config VTuber client, we have folder notifications, and in the notifications folder we have, for example, follow notif, and then just simple toml file. So we can select what sound it will play. There is the template text for we replace the username with the actual username that follows me. We have offset for the text from the top left corner origin of the image if there is one. For example, donate has image. This is just example, this is not actual image, but it works like this. It's able to serialize that stuff, it's able to load the resources into memory, and yeah. We did that in previous stream too. We load all the notifications, as you can see here. We load the resources, and then we print them. And then we started learning the Vulkan. So I think we can continue. I deleted the useless stuff that we didn't actually need because it was just for learning itself. And we can continue with chapter 5. Boom. And we are here. So, creating image. In the buffers creation section of the book, we saw that in order for the GPU to access data, we had to put it in buffer. This is not exactly true, as there is alternative, which are images. An image in the context of Vulkan designates a multidimensional array of pixels. There are various hard-coded formats that the pixels of image can use. Example of the various images used by Vulkan using application is seen from debugger. We often use Vulkan images to store images in the common sense of the word, in which case each value of the array contains the color of the pixel. However, Vulkan images can also be used to store arbitrary data, in other words, not just colors. Note, pixels inside images are sometimes called texels, which is short for texture pixel. Okay, that's good to know. Textures are a more specialized alternative to images, but that no longer exists in Vulkan. The word texel has been less and less used over time, but the word texture is still very common. Properties of I cannot talk. Properties of an image. Well, we often think of images as being two-dimensional. In the context of Vulkan, they can also be one-dimensional or three-dimensional. The dimensions of an image are chosen when you create it. There are two kinds of 3D two-dimensional images, actually three-dimensional images, and arrays of two-dimensional layers. The difference is that with the former, the layers are expected to be contiguous, while for the latter, you can manage layers individually as if they were separate two-dimensional images. Okay. Okay. Arrays of two layers. Right. When you create an image, you must also choose format for its pixels. Depending on the format, the pixels of an image can have between 1 and 4 components. In other words, each pixel is an array of 1 to 4 values. The 4 components are named in order RGB, which is for red, green, blue, and alpha. How translucent the pixel is. If you are familiar with RGBA, it may seem obvious to you that the R component, the first, is supposed to contain the red value of the pixel, the G component, the second, is supposed to contain the green value of the pixel, and same for blue and alpha. However, remember that we can store arbitrary data in this format instead of colors. You can check the list of all available formats here. Let's check that actually. Wait, bro. It opened somewhere else again. Where are you opening this stuff? Here? Here. Oh my god, there is so much stuff actually. Hi Arisha, how's day going? Hi Jimmy, it's going fine. It's going fine. I'm extremely late today because I fell asleep. I fell asleep and started streaming 2 hours late, but yeah. Doing fine. How are you, Jimmy? How are you doing? I hope you're doing good. I hope you're having a good day. But yeah, these are the formats. Sleep is good. Sleep is good. I cannot deny that. But yeah, we can see these formats that... So basically, images can have these color formats. There is a lot of them. There is like 200 of these. Yeah. Wow. Right. I'm doing well. Good. I'm glad. And that makes me happy you're doing well. For example, if you create an image with the format R8 signed integer, then it will only have one component. But with the format 8UR1, 0G, 10B, 10S signed scaled back 32-bit integer. You have all 4 components. The first part of the name of each format corresponds to the memory layout of the 4 components. For example, with B10, G11, R11, unsigned float, packed in 32-bit value. I guess each pixel is 32 bits long, where the first 10 bits is the blue component, the next 11 bits are the green component, and the last 11 bits are the red component. Don't worry if you're confused, as we will use the most similar formats in this book. Right, so it is, how I said, it's basically unsigned float packed into only 32 bits. So all these values are packed into 32 bits. So it's one simple value you can copy very easily into CPU, and it's very accessible and stuff. So this is just 32-bit integer, you could say, separated at bit level. So it's like bit flux, right, or something like that, you could say. Image creation. Similar to buffers, images are created by providing information about the image and allocation. However, unlike buffers, images always begin in an initialized state. Okay, let's check what we have here. I usually copy the code and check it in my text editor because it's more readable, I think, in here. Oh, unresolved import. Oh, really? I missed some snippet? No. That's interesting. Let's check image no dimension. It's not there. Interesting. Let's see. So we just call image new, we use the memory allocator, we clone the reference to it. We need image create info. Let's import that. And we need image type. Let's import that. Image usage. Boom. And we don't need image dimensions, do we? Yeah, I don't think we actually need this import. Yeah, this stuff is too complicated for me. That's okay. It's not for everyone, right? It's not for everyone. But I want to learn it. I want to learn it. It's stuff I like and stuff I want to work on. Is an image dimension just defining the boundaries of the image? Yeah, which is, I guess, here? No, image type dimension 2D. I guess it got renamed, right? You can just placeholder tracks. Yeah, I think it's this. Look at this. Image type. And we have dimension 1D, 2D, and 3D. I think it's this. But it got renamed in update. So when we check here, this is actually outdated, right? It's outdated. But that's okay. We figured out it's actually image type. They use just different import for the stuff. Good for big smart girl. Oh, this. Yeah. I'm not very smart, but yeah. I think it was just, there was some update and they changed how you're supposed to import these stuff or such. Big brain Arisha. I'm not big brain. But yeah. As we can see, these are the dimensions. So I just think it was like inter import, there was supposed to be image type, but now it's in different import. We can actually check it. Where is it? Here. Let's actually just steal that. Let's steal that from here. Boom. Let's go down and plop it in here. So we do like use Vulkan image. Boom. And it's this basically. Instead of the image dimensions, we have to import 3 components by itself. Before they had some like prelude or something, some module that imported all of this stuff. But now they separated the stuff. Props to have recalled dim to undefined parameters from there, so you can have multiple images with some dimension props. Instead of setting dimension for each one, maybe. No. I will show you what the thing was. I will show you. So, in the Rust, you can create a module like this. Let's call it image dimensions. Boom. And you can do like pub mode, like Vulkan image, and you do basically this stuff. You do this, and I'm assuming in previous version they just told you to import this module that already had like pub use and imported these specific elements, but they had, for some reason, they had module for importing these 3 elements. I'm not sure why, but they obviously removed it, so it was a bad idea. They removed the module for importing this stuff. I slept so late. Oh, welcome to the stream, Hazune. I hope your sleep's very good. How were your sleeps? create info. DRM format modifiers. Arisha learning how to do DRM now. No, I'm not. That's just some additional info that I don't know, right? It's just that's coincidence that is something like that. I was just showing how it changed. I was just showing how the image dimensions module changed to just image create info. But there is DRM stuff actually. You can change some DRM for images and such. Allocate image error. Yeah. We don't need to know about that now. Boom. So we just create new image. We pass the memory allocator with automatically reference counter. We create image create info, which is information about the image. So image type is dimensional, 2D dimensional. We have the format, which is 4 8-bit values, which can be packed into 32-bit number, which is like, for example, unsigned 32 is 30-bit value, so you can put all of this stuff, RA, GA, BA, AA, into one int. Because it's packed together, it shows the bits. I fully understand everything. Good. I hope you're hydrating, Hazunia. I hope you're hydrating. What's extent? That's extent the width, the height, and depth of the image. If image type is image type dimensional 2, then the depth must be 1. If image type is dimensional 1, then the height and depth must be 1. The default value is 0, 3 zeros, array of 3 zeros, which must be overridden, okay? I'm Arisha, milk and water. And in usage, how the image is going to be used. The default value is empty, which must be overridden. We have image usage struct. Describes how the image is going to be used. This is not just optimization, but it helps the optimization, and it's also for a different reason. Couple clementines bit later too. Clementines? What does that mean? Is that alcohol? Hazunia! If you try to use image in a way that you didn't declare, error will occur. So we are saying this can be transfer destination, so we can actually transfer data into this image, which is like buffer. It's the same thing as buffer. Type of mandarin, Arisha. Ooh, I hope it was yummy. I love mandarins. They are so good and juicy. I hope it was yummy and juicy. So we can actually transfer data in this buffer, because image is just buffer. Image is just buffer. It's just buffer with some more type definitions, right? So we can transfer into it, and we can use it as transfer source. So if we have already image in it, we can transfer from this buffer into a different buffer. And here we are supplying the allocation create info, and we are telling the memory type filter to be preferred device, which means it will be in the video RAM. So this buffer will be created in the video RAM. You know I don't drink alcohol or smoke. Good girl. What a good girl you are, Hazunia. What a good girl. You can continue. We explained what it does. We explained the issue with the image dimensions. We even found pull requests for the changes. I'm glad you understand this. Oh, I don't know how to explain it better. In previous stream, we explained the buffers, right? So if you want to properly understand this stuff now, you should probably check my previous stream where we actually learned about the buffers, right? In previous stream, we learned about the buffers. We learned about command buffers, we learned about normal buffers. For example here, as you can see, this is normal buffer, and it's the same thing. The only thing that's basically changed is it's renamed. It doesn't have buffer create info, it is image create info, and it is additional information about image. But it's the same thing. You pass memory allocator, you pass memory type filter, and yeah, it's the same as buffer. You just have more, it's more typed for image, so it's easier to use for programmer. Also, I love your accent. Oh, thank you so much, Goldmine. That's very sweet. Thank you so much. Thank you. I'm glad you like it. But yeah, when you go onto my channel, which we are here now, like this, and check here, there is a button for VODs. If you go to the VODs, it will throw you onto YouTube, and onto YouTube, there is you can go to playlists, and there is playlist called programming. You can click view full playlist, and this is the stream 1 day ago. It's 6-hour stream, and we went over the buffers, we went over all that stuff. Already did. Oh, good. Can you imagine someone not loving it? Go to YouTube, not what hasn't yet said. Huh? Yeah, where is the tutorial here? So let's continue. We pass the dimensions of the image and the desired format. Just like buffers, images also need to be created with flags that describe how the image will be used, and using it in a way that wasn't specified when creating it will result in error. Good. So, clearing an image. I actually have here extension that can read it. I can actually use the Google Translate so it can read it. Yeah, we are not doing that. Past the dimensions, Arisha creating portals like Doctor Strange. I am creating portals. So, contrary to buffers, images have opaque implementation-specific memory layout. What this means is that you cannot modify image by directly writing to its memory. There is no such thing as CPU-accessible image. Okay. In reality, Vulkan also allows you to create linear images, which can be modified but are much slower and are supposed to be used only in some limited situations. Vulkan doesn't support them yet. Okay. Therefore, the only way to read or write to an image is to ask the GPU to do it. Huh. Okay. This is exactly what we are going to do by asking the GPU to fill our image with specific color. This is called clearing an image. So here is the code. Oh, it's another command buffer. Good. Boom, boom, and let's check. So we import from command buffer the command for clear color image, which is just fill basically. It's just fill image, and it has special command for it that we send to the GPU. We create the command buffer builder on our command buffer allocator with the Q family we are using, and it will be submitted only one time. Command buffer usage. Then we click on the grab the builder. We tell it what to do, which is clear color image. We supply struct clear color image that is the clear value, so we can change the color of it. We can make it, this for example will be blue image. this right now will be blue image, but I want to make it, for example, red and green, which will be yellow. This should be yellow color if I'm not wrong. And then we just copy the information from the image itself to fill the information clear color, which is the image layout, and regions. And we built the command buffer. Now we need to actually send it and wait on the future, which is like interrupt from the GPU. It will interrupt our CPU and it will tell, hey, I'm finished. Right, the GPU will tell our CPU, hey, I'm finished. The function is called clearing color image as opposed to depth or stencil images, which we haven't covered yet. Normalized components. The clear color value and enum indicates which color to fill the image with. Depending on the format of the image, we have to use the right enum variant of clear value. Okay, because they're different, right? We can actually check it out. Like this. What we have int, we have uint, we have float, right? And we are using float. If we check above, we created image with unorm, which is, I guess, 32-bit float. Yeah. Wait, what is this? What? What? What is wrong here? What have I done? Is it here? For is private enum. Oh, was that the error before in there? I didn't see it. Oh no. Format, really? Use volcano. Format. Image format is private enum. Oh no. Oh no. Numeric format. What do you take? Format undefined. Format. It takes this format. What is this one? It's just format. Are you trying to get into enum's private nude stash? Shake my head. I'm not. I think it's just LSP error. I think it's LSP error how I went into the stuff. Look, it will work now. It was just LSP error. Look at this. Now when I go here, boom, it will work. Right. No. Wait, I'm confused now. It didn't show this error before. And it's not updating actually. Oh, it's okay. It was because I jumped into the source code of the library. Look, it compiles. It's actually okay. Oh my god. I was bamboozled. The LSP, the language server, got confused. It's actually okay. It's actually okay. It bamboozled me. Oh my god. Okay. Where did we end? Here we pass floating point values because the image was created with RGB unorm format. RGB part means that 4 components are stored in 8 bits each, while the unorm suffix means unsigned, normalized. The coordinates being normalized means that their value in memory ranging between 0 and 255 is interpreted as floating point values, and the memory value 0 is interpreted as the floating point 00, and in the memory value 255 is interpreted as the floating point 0. I mean 1, 0. Okay, I understand. So it's using actually 255, which is 8 bits, to encapsulate the float, which is not very accurate. That's not very accurate, but it's enough to have 255 positions, I guess. So it's completely okay to use it for color, as long it's the range between 0 and 255, which is 8 bits. Which is like minimum really for color format. Okay, so normalized just means it's float. Normalized is float. That's good to know. Normalized is float. Norm. And the U before it means unsigned, of course. With any format whose suffix is unorm, but also snorm and sRGB, all the operations that are performed on the image, with the exception of the memory copies, treat the image as if it contained floating point values. This is the reason why we pass 0011. The values 1 will in fact be stored as 255 in memory. 8-bit like old Sega consoles. But this is only for like one value, right? You have 8 bits for red, you have 8 bits for green, you have 8 bits for blue, and 8 bits for alpha, so you can make it translucent. Boom. I will hydrate. Everyone hydrate too. Good. I needed to hydrate. Right, so exporting the content of an image does that make 500, 200 bits? What? No. In total, it's 32 bits, because you are saving 4 8-bit values in that format we found. Where is it? This one. In format. It didn't copy the stuff. It's 32 bits. Because we have 8 bits of red, we have 8 bits of green, 8 bits of blue, and 8 bits of A, which is everything is basically from 0 to 255. And 0 to 255 is 8 bits. You can store all the numbers from 0 to 255 in only 8 bits, right? You can make 255 combinations in 8 bits. Okay, that's not combinations, but I don't know the word in English now. But it's 32 bits. It's normal unsigned float. It's unsigned. It's 32-bit unsigned float, and it's packed into it. So it's in one value, very simple value that you can copy super quickly on CPU. Okay, to continue. Exporting the content of an image. In previous section we filled the image with color, but you may now wonder how to see the result of this operation. As explained previously, images are opaque structures whose actual layout is implementation specific, so how do we read their content? The answer to this question is that we have to create buffer and ask the GPU to copy the content of the image to the buffer. Yeah, they did it later, okay. I cannot imagine what else it would be other than combinations. Should I explain it? Okay, I think we could explain it. Right. How could I explain it? Let's open Krita. New match, I mean with other word. Oh. Well, it's not it's like... It's like, I would, maybe the more better word is more like sad, maybe. Like sad is more correct. Right. Let's do bits to number. Let's find some website that does binary to decimal. So for example, we will put... Okay, this is terrible actually. I don't like these websites. Rust Playground. I want a Rust Playground, please. How about coordinations? I don't think I would call it coordinations too. And I'm sorry if you hear my dogs barking. I don't know what's happening. Yeah. But yeah, we have binary value here. Right. And now, to show you, I guess. Oh my god, there is no way. Oh, I don't have my Vim stuff. Can I use Vim? Keybinds. Vim. I hope it works. It works. Okay, it works. I can use Vim in here. Oh my god, God bless. God bless. How should we name it? Let's just name it oh, okay. Okay, it doesn't work. The Vim doesn't work completely. Ugh. They're just keeping you safe. I cannot use escape to escape it. What? How do I escape? I want into normal mode. Okay. That's annoying. Groovebox. Where was Groovebox? I seen it somewhere. Here, dark. Let's do something like this. I don't know how to use normal editing stuff. Oh my god. That's annoying. I actually don't know how to use it. I know how to use Vim, not this stuff. I completely forgot. Oh my god. Oh. Oh. Now I want you to copy the stuff. What are you doing? It's not copying. Oh my god, this is such a bullshit. I'm so sorry. This is this is terrible. Okay, let's not go into insert mode because insert mode is broken. I want this to be 0. Boom. And now it's broken again, of course. It's okay, Arish, I don't need to worry about it for my sake. It just perils for the swine anyway. It's okay, we have time. We don't have to, you know, limit ourselves. But I don't know why the Vim stuff doesn't work. I think I know why, actually. I know why why it doesn't work. Right. Chromium. Private window. Can you open just private window? It's not, whatever. Is there a share button? Share. okay, it's too wide, so we change it. Hopefully here the Vim will work better, because I have already extension for Vim in my browser. Right. What are you doing? Can you just share it or something? I want to copy it. I swear. Permalink to the back. Yes, to give me permalink. Do you give me the permalink? It's here, okay. Oof. Good. Go away. Now, please work. It works. Now I can show you the stuff. So we just print the numbers, right? We could print it in binary thing. But I want to print it as a normal number. So we just go like this. And let's run it. So as you can see, it's 0, 1, 2, 3. Which makes sense, right? Because look at this. I'll do something like this. Oh my god. This is 8, 7, 6, 5, 4, 3, 2, 1. If I'm not wrong. So if we now change, for example, 8, or if we have the 8-bit set to 1 and only the first bit set to 1, and we print it, it should be 9. Oh yeah, this must be comment. Run. It should be 9. It's not 9 because I'm stupid. See, I'm not smart. I'm not smart. I actually don't know. This worked. Yeah, I was wrong. I was super wrong. This is 4, this is 8. So we have to change this one to 1. We have to change the 4th bit to 1, and we should have 9. Yes, that's correct. It's basically like just a plus, right? And it goes like this. So the 5th bit is 16. The 5th bit is 16. Move. The 7th bit is 32. The 7th bit is 64. And the 8th bit is 128. This is how it's like a representation. And you just, for every... Oh my god, it's still weird. The Vim is still weird. For basically every bit you switch, up, you switch to 1, it will like, how do you say it? Sum it. It will sum it. It's basically that simple. So if we, for example, do 5th bit is 1 and the 8th bit is 1 and first bit is 0, this will be 48. So if we run it, this will be yeah, if we actually could put this away like this, it will be 48. Boom, it's 48. It's just like summing the numbers, right? It's like the representation of it is in the bits, which is 0 or 1, and we have 8-bit number. This is basically 8-bit number I'm showing up. The type is not actually 8-bit because default integer is 32 bits, but that doesn't matter. We are using only the 8 bits right now. So I'm showing you the 8 bits. This is the binary representation, and when I want 64, when I want to add to the number 64, I just switch the bit up onto the 64, onto 7th bit, and I run it, and it will add 64 to 48, which is, I think, very cool. We can actually do something like this. I don't think that's needed, but 64 plus what was it? 32 and plus 16 will be 112. So when we run it, boom. It's how binary. It's how it works. Isn't that actually simple? And why is the theme not working? Why is it still white? Do we understand it? I don't know. I don't have words to explain it like in best. We just have 8 bits, and every bit represents some value. And if you switch that bit up, you sum the values of the bit. So 8 bit is 128, and if you want 129, you just set the bit for 128 to 1, and for the 1, you set 1 here, and we will have 129. Yeah. I hope I explained it somehow. I know it wasn't best, but I hope you now understand it better. I'm so sorry, I tried. Oh, I see. We are just like setting which... I really don't have words to describe it. I'm so sorry, I'm not a native speaker, right? I'm not native speaker of English or such. And I don't have a dictionary for it. I try to at least show it how it works. I made a presentation of it, how it works. 8-bit is 128, 7-bit is 64, first bit is only 1. It's just simple conversion from 10 base to 2 base. Yes! Yes, that's it. That's basically it. Oh my god. See, I'm terrible at explaining stuff. But I hope I could enlighten someone in some way, if you understood it. Let's continue. So, copying through the image to the buffer. The first step is to create the buffer, as we have already covered in previous sections. The buffer has to be large enough, otherwise the copy will result in error. Each pixel of the image contains 4 unsigned and 8-bit values, and the image dimensions are 1024 by 1024 pixels, hence why the number of elements in the buffer is 1024 multiplied by 4. Okay, let's copy this and let's look at it. So we are creating buffer from iterator. We pass the memory allocator for the GPU. We create buffer create info, and we set it. The buffer is used for transfer destination, so we can transfer stuff into this buffer, and it's allocated onto host, so it's onto like normal RAM, it's not into video RAM, and host has random access to it. And we just initialize the value, which is done here with the iterator. You don't have to do it with iterator actually. You can just do it from data, for example, and we can change this line. We can change this line to something like this. Look at it. We can put this here, and we have 24, 1024 multiplied by 1024 multiplied by 4. Boom, and this should be okay too. This is basically the same thing. They just used iterators for some reason from iterator, so they created iterator. But this is the same thing and it's faster. But the compiler in a release mode will probably do the exactly same instructions on the CPU when initializing this stuff, so it doesn't matter. The compilers are really smart actually. So we just initialize buffer from which we can copy. And let's modify the command buffer we created in previous section to add the copy operation. So let's copy this, let's look at it. Boom. Oh yeah, it's moved, right. Yeah, they don't want us to do this here actually. We have to comment this out. Because we are doing the clear image here. We have to because command buffer, we want to do it, we want to send multiple commands at once, because sending one command by one command is very inefficient. To send one command to the GPU takes microseconds, which is a lot, like 200 microseconds, the guide told us, which is massive time for GPU and computation. So we want to actually put as most commands into one command buffer and then send the command buffer to the GPU. So we are not sending one by one, we send a whole list of commands at once, right? So we first clear the image is buff, then we copy image buffer from image, which is the now filled with the colors. Actually, I want to change it again to yellow one, so let's change it to half red, half green, and let's remove blue. And we have yellow image now. And we want to copy the image into this new buffer that's accessible by CPU. Because this image, the pure data of the image, is not accessible by CPU, so we cannot actually show it. We have to first copy the data from the image buffer in the normal buffer that's accessible by our CPU, so we can actually show it on the computer, right? We need to show it on the computer. Since this is memory transfer operation, this time the image values are not interpreted as floating point values. The memory content of the image inside 8-bit values is directly copied to the buffer bit by bit. Let's not forget, or more specifically, like threaded 2 bits by threaded 2 bits, but that's optimization, we do, never mind. Let's not forget to execute the command buffer and block until operation is finished. Yes, we have to, of course, synchronize with the GPU. We have to, how do I say it? Good question, how do I say it? And you have wrong here thingy. How is it called? Command buffer. Where did I initialize it? It's just builder. It's not actually called. Yeah. Builder. No. Wait, what? What have I done wrong? What have I done wrong? Buffer. Where? Oh. Oh, we didn't build it. Right. I commented that out. That's actually what we need, but we need it after this. They don't have it really complete. the snippets, so we have to like fix them ourselves. We have to fix the snippets by ourselves. Maybe I could later make a pull request to fix it. Maybe. But yeah, so we synchronize, we basically take the device, we execute on the CLUD, on the queue we are using our command buffer, then we wait for the GPU to interrupt our CPU to tell us, hey, it's finished. So we create future for it, and we wait on the future and we give it no timeout. So we are giving it basically infinite time, and yeah, there's no timeout. We can read here. If timeout is none, then the wait is infinite. So the operation cannot time out. Otherwise the thread will unblock after the specified timeout has elapsed and an error will be returned. So that's in case the GPU freezes or something. Right, or if the operation takes too long, you don't want the program to freeze, you put timeout in there so it doesn't freeze your program. So you can recover from GPU errors like this. Now, turning the image into PNG. Now that we have buffer that contains our image data, we will visualize it by saving it as PNG file. The Rust ecosystem has great name image that can do this. Let's add it to our cargo toml. Okay. I think I have it already. I have it already. Okay. We have it already. We have that crate already. It's okay. In this library, the main timer represents image is the image buffer. It can be created from slice. Okay. By the way, I'm not using this copy button because it copies it in main function, which is annoying. So I'm using normal select and copy because the copy button is terrible. Was going to say that sounded like it would have potential to freeze the program at least, if not more. Yeah, and it allows you to time out. So if it takes like over you can set it. If 3 seconds, it errors out. Right, so you can catch errors that the GPU, or if it takes, you sent wrong command to the GPU, it takes too long, you can time out the stuff and, hey, something went wrong. It doesn't freeze your program forever. It waits, and if the timeout runs out, it just errors out, which is very nice. But we read the buffer and the sub buffer, obviously, that's okay. Then the image buffer we create from raw image. We set the size and we take the buffer image stuff. And now we just need to save it. Boom. And now let's save the image. And now we have to run it. So let's run VTuber client. Oh. Oh. me overflowed the stack. How big is it? I mean, damn. Okay. They don't have this issue here. They don't have the issue about it because we are doing the compute above. It's just not enough for the stack, really. Then we shouldn't use. Oh, I know why. You know why? That's why they used iter here. Do you remember when I removed the iterator from here? For it to be only this? I think that's the issue. Because it's not dynamic memory. It's on the stack. It's on the stack. And it's too big. Oopsie. let's fix it. At least I remember what I changed, you know? At least I remember what I changed. Where is it? Where is it? Come on. I need to find it. Here. You meet this line. Boom. And now you want it from iterator. Itera. Boom. And now it should work. So that's why it was itera. Because they want it to be dynamic. Because otherwise it overflows the stack. Oh my god. That's good to know. Yeah, it worked. It worked. It worked. I knew it. I knew it. Okay, let's open the image now. Let's open the image. So where is it? Image PNG. It's here. Okay, let's see. It should be yellow, I think. Half red and half green should be yellow, right? Oh my god, it's yellow. It's yellow. It's kind of disgusting yellow. But it's yellow. Isn't that cool? Isn't that cool? We created this image on the GPU. We created this image on the GPU and saved it in the file. I think that's really cool. That is the most disgusting yellow I have seen in a while. It is. Oh my god. It's disgusting yellow. I cannot disagree, okay? But it's image. It's actual image we created on the GPU. Look at this. We told the GPU to fill the image with this color. We told the GPU. Now let's try to make the color nicer. let's try to make it nicer. Okay, let's make it more yellow. Let's make it more yellow. Like this, and maybe a little bit of blue into it. Let's see what will happen. Let's run it again. Image boom. That's better yellow, I guess. This is very nice yellow, I think. It's still not best, okay, it's still not best. A little better. Thank you, Azunia. But yeah, we created the image on the GPU on different device, basically. It's different device connected through PCI bus. We told the different CPU from our CPU to create this image and send it back through the PCI bus. And then we saved it in the file. Isn't that crazy? I think that's crazy. I think that's crazy. Oh, that's it. When running your program, blue image named image PNG should appear. Boom. Of course, we changed the color. I didn't want blue one because blue hurts my eyes. This intense blue color hurts my eyes. This might look stupid, but think about the fact that it's the GPU that wrote the content of the image. Exactly. It's run on different device. It's different CPU connected through wires, through PCI bus. And we told it to do this. I think that's really amazing. In me doesn't seem like much at this moment, but it's really amazing, I think. It doesn't make sense. Blue light has the most energy. Yeah, it hurts my eyes. Let's move as quick as possible. In the next section, we will do more than just fill image with blue, but we will continue to retrieve the image content and write it to PNG file. Boom. I'm happy. I don't know how you are feeling, people in chat, but I'm happy. I mean, this is amazing. I think it's amazing. Yeah. But now we at least know we shouldn't use stack for it. We should allocate dynamic memory. That's why they are using iterator and not actually stack. That's good to know. I too like green a little more. Green is a very nice color. I like brown. I like really brown color. I don't know why, but some brown colors just, they're so comfy to look at. Useless princess, getting back to the start of this madness. Why do you even need free capability in your helper software for streaming? Why not just simple 2D drawing library like Cairo? But I will be doing 2D, but also 3D. That's the thing. For alerts, it will be 2D, mostly, but for VTuber, because this program will be stream overlay, so it will be showing alerts with my VTuber. So, and in future, I wanted to support 3D VTuber and stuff, 3D VTubers, 3D models, and all this. So I'm creating my own stuff with the Vulkan API, and we are learning the Vulkan API right now. I want to use Vulkan. I always wanted to learn it, even if it's hard. I wanted to learn it because it will give me insight into how the GPU works. I will know more, and I want to know more. It makes me happy. The more I know, the happier I am. Are she getting the roundest of boobas and she going to program heavy gravity effects onto them? I will, Hazunia. You're right. I will, Hazunia. If you aren't doing 5D, why even bother? I will be doing 4D. That isn't enough. I will be using quaternions. I will be using quaternions for direction stuff. 3D vitamin scan animation. Not many people use it. Most people just use VTube Studio. You could try that in Steam Proto. But I don't want to use someone else's stuff. I want to create my own XLR. I like programming. I want to do mine. Shake my head, not far. Quaternion. This is 4-dimensional vector, or how to call it. I heard of them. Yeah, I will be using this for orientation. T-poses over all of you in 6D. Yeah, I will be using this for calculating orientation, direction, and stuff. It's very interesting. I will be explaining quaternions in future streams when I will be working on the direction stuff and all that. I will be explaining quaternions, but I definitely recommend to look it up yourself. There is a lot of good videos about them, and quaternions are really amazing. Like they are a godsend. They are a godsend. I don't know how we would do this stuff otherwise. It's just amazing. Quaternions, I love them. But I don't want to use VTube Studio or VC Face or Minion or other things like this. I want to make my own stuff. The problem I can see is the baked knee, not invented here syndrome. You would clear the profit from using established VTubing standards and creating something from scratch, in essence replicating work that had already been done. But I want to do it. I want to do it for myself. It's my... this is my content I will be doing, right? This is what I will be streaming. I have fun with it. I have some people that enjoy it. It's something I like. I enjoy doing, and I want to do my own stuff. I will of course support like the common VTuber formats like VRM and etc. But I just want to make my own stuff because I want my things. I want to work the way I want, right? I want it to work the way I want. I heard when you get into extremely complex 3D modeling, quaternions make you want to cry, but that's like crazy high level modeling. I feel like quaternions make it easy actually. It doesn't seem like it, but I feel like quaternions makes 3D stuff easy. Yeah, I think quaternions make it easy actually. It's hard to understand at first, but after you understand, I feel like it makes it easy. I don't know. Depends for each person, of course. Matrix calculations. I haven't seen matrices since I got out of university. I cannot even remember how to make matrix calculations anymore. It wasn't all that complicated from what I remember. Yeah, matrix calculations are not that complicated. Arisa is just very smart. I'm not smart. I'm not. I'm like the stupidest person you know. I swear. I promise. I'm like the stupidest person you know right now. Especially in mathematics. I'm terrible in mathematics, okay? I'm terrible. I was worst in my class. I dropped out because of math. Because of math class. So I'm very dumb in math. I'm very dumb. Let's read this. Chapter 5.4. Drawing a fractal with compute shader. We are going to draw fractal. Do they have image of it? They have. Oh my god, okay. Okay, let's do it. Let's draw a fractal. Okay, I guess we can comment this out. I think we can comment all of this stuff out. Let's continue for now. I love math. It's either true or not. It's fully logical with no nuance or hidden things or interpretations or anything. I love math too. That's the thing. I love mathematics. But I had this whole issue with teachers and the school. It just there were issues. So it fucked me up, right? But I love mathematics. But as I said, I'm terrible at them. Ah yes, teachers can be asked. Well, yeah. For example, at elemental school, our teachers changed every 2 months for mathematics. Our teacher, we had different teacher every 2 months. We had like 8 teachers in 1 year. It was massacre. So basically they ruined my basics, and then when I went into high school, the teacher that was there was absolute asshole. Like absolute asshole. He made basically he made two students from my class attempt suicide. It was terrible. And he was throwing keys at people. That means you were bad with your teachers, not that you were bad at math, but I didn't catch up. That sounds heavily illegal. Well, yeah. I don't think it's illegal, actually. Maybe it is, I don't know. But it happened. Let's move on. I don't want to talk about it. I don't have good memories on it, especially from there. Right. Drawing fractal with compute shader. This section isn't going to introduce any new concept, but will show a real-world example by using compute shader to write Mandelbrot set to an image. Yeah, I cannot blame you. Just like in the introduction to compute pipelines, we need to write some GLSL code and create compute pipeline. This is done with the Vulkan under the macro as explained in that section. Each invocation of the main function of the shader will write 1 pixel. Yes. You can find the full source code here. Tada. The shader. Let's spend some time on the GLSL code of the shader which I wrote for you. Okay, let's just copy that stuff. I have to learn shaders somewhere. I don't know how, because this tutorial is not focusing on shaders. This tutorial doesn't teach you shaders, so I have to find different tutorial or something where to actually learn the shaders. It obviously looks like C, right? It looks like C. It's basically C if we don't look at this. The layouts. I need to learn about the layouts properly. Use imaginary channel points for hydration, snack and stretch. Ugh. Okay. Let me hydrate. You hydrate too. Everyone hydrate. Hydrated. I have no snacks, so I'm sorry. I will stretch. No, I stretched. Why are you laughing? What is this? What emote should I use? Boom. Okay, so this code. So shader. Fract is compute shader, so let's call it fract compute. Right, and let's paste this in. As you can see, I have the syntax highlighting. For the GLSL shaders. Too adorable. I'm not adorable. I was laughing at you going, we need to learn about shaders, we'll just copy all this. Because it's such a familiar thing when I'm teaching myself things. Well, that's the thing. This tutorial isn't focusing on shaders, it's focusing on how to use the Vulkan API. Right. Shaders are different thing. Shaders are not like related to it. Right. I could maybe, next stream could be about learning actually shader language, right? Next stream could be about learning shader language. Yeah. I mean, we can kinda understand what's happening here if you look at it. Kinda. Like, I know what's happening here. You can read it, but it's not hard to read it. You, for example, don't have to understand the formula, mathematics formulas, like what they do exactly, but yeah, I don't understand the layouts especially. I have problem with the layouts. Like, I understand we are saying the first thing we are supplying in will be in set 0 with binding 0, and it will be in format RGBA8, and it will be uniform, which means it's unsigned float, it's write only, and it's image 2D, and it's named image. But I actually don't have the understanding to, like, I can read it, but I cannot, if this wouldn't be here, I have no idea what I'm supposed to do, right? I can read it, but I have no idea what I'm supposed to, if this wasn't here, I have no idea how to do it. I imagine the layout essentially just formats the matrix you want to use. Well, I know what set and binding does. Set and binding, you basically specify data you're sending into the shader, right? And then you have additional options, I guess. I don't know what this layout does at all. I know it's accepting something in, obviously, because it's called in, so something is going in. It's UFloat, you can write into it only, it's type image 2, handle fractals in 2D texture. Yeah. Alright, we have the shader. Now we need to put it here. Let's put it in the same shader actually, you know what? Let's put it in the same shader. Let's call it shader like this, or... You know what? Let's call it shaders. Boom. And now, how are you supposed to do the shader? It was shown here. For multiple shaders in one macro. There was specific, yes, this one. Let's copy this stuff and let's try it. Boom. Really? It's like this. Okay, how should we name it? Let's name this one just main. Let's name this one main. This will be the compute, and it will be from this file. So oh my god. So it will be path and oh my god. Copy this. Boom. It doesn't have good formatting. Oof, it doesn't have good formatting. Okay, and now we need to add the fractal shader. Right, so we do like fract, maybe, with something like this. We add source. Oh my god, why is it computer? It's actually explaining the shader here. Why not? Okay, it's actually explaining the shader, but I just want to write it in right now. This is type, not source. Okay. Okay. I was doing it a little bit wrong. It's type. And now fract, boom, and it will be type, it will be again compute, right? And path will be shaders fract comp. Was it like this? This is horrible formatting. Can I somehow at least like this? Okay, this is nicer, but I did wrong name. Like this. Let's check how I named the shader. It's actually called fract, which is correct. Yeah, and now we are compiling two shaders, which of course there will be error. There will be error because it changes the load function. Yes, we have to call it main load. No, it's load main. Okay, it's different. It's load main. Good. This is how we load the shader actually. So we are loading the first one for the previous thing, which is okay. And yes. And now we can work with the fractal shader. Oh, that's cute tail. Oh, that's cute tail. Oh, cute happy waggies. Oh, happy tail wags. Boom. Very cute. Let's print that. I like that. Did it pin something went wrong? Please try again. Oh my god. Refresh. Oh, it's pinned. Okay, it's pinned. It's pinned. We have now tail all the time in chat. Nice. I like cute things. So now the shader. Let's look at their explanation of the shader. Right. This will be fun. Let's go through this line by line. So this layout, local size X, local size Y, local size Z, in. For better parallelization, we decided that each invocation of the shader would write a value to pixel of the image. As you can see, this time we use local size of 8 times 8, which is 2-dimensional. We will use the value of GL global invocation ID to decide which pixel we will write. Oh, okay, I understand this now. It's like how we want to invoke it. It's how we want to invoke it. How many parallelization it should have. I guess. We decided that each invocation of the shader should write value to pixel of the image. As you can see, this image we use local size of 8.8, which will use the value of invocation to decide which pixel we will write. Okay, let's continue. This layout set bindings set and binding RGBA uniform write on image to the image. This line declares the presence of an image that we are going to use. At slot 0 of the descriptor set 0. As you can see, we have to specify its format. Trying to use an image whose format doesn't match what is expected will result in error. Okay. Norm coordinates. So we normalize the coordinates. These lines declare two variables whose type is vector 2. A vector 2 is equivalent to array of two floating numbers 32 bits, and it's usually used to store 3 coordinates. Similarly, IVEC4 is, for example, equivalent to a signed integer 32 bits for array. Unsigned vector 3 is equivalent to unsigned 32-bit integer 3, and so on. The Mandelbrot set is set of complex numbers. So in this shader, we use several vectors to store the real and imaginary parts of the complex numbers that we manipulate. The purpose of these two lines is to put it in the variable c, the complex number that corresponds to pixel of the image that we modify. The pixel that we are going to write will have color that depends on whether or not its corresponding complex number is within the set or not. So this is deciding the color based if it's within the set or not. We now want to find out whether the complex number that we are manipulating, C, is within the Mandelbrot set. The definition of Mandelbrot set says the number C is within the set if the function fz equals, how do I say this in English? Does anyone know how I say this in English? Right. I'm so sorry. Z squared or z to the power of... Okay. So we have function that takes... squared. Squared is always 2. Yeah. I know. I know that. So, I will probably say z to the power of 2 plus c, which is the complex number. Diverges when iterated from z equals 0, z being complex number. That is exactly what we do in this code. We start from z vector 2, 0, 0, iterate with for loop. Keep this always to the power of 3. Each iteration puts the value of the next iteration in z and checks whether it is diverging. We consider that it is diverging if length z is bigger than 4. The length function is built-in function in GLSL. You can find its definition and the definitions of all the built-in functions at docs.gl. Okay, this will be very important, I think. I mean, I have the thingy, right? So if I write length, it actually shows me auto-completion. It actually shows me the auto-completion because I have the GLSL, analyzer. What we have left at the end of the for loop is the I variable. If the complex number is in the set, then the function didn't diverge. The for loop went to the end and I will contain one float. Otherwise, complex number is not within the set and I will contain number between 0 and 1. The closer C is to the set, the higher I will be. Therefore, the value of I is what we are going to store in our image. Makes sense. Vec4 to write vec I with alpha 1 or yes. So this is the color and this is the alpha. So the alpha is always full and the color is based on the I. And an image store let's read. In these two lines, vec4, vec3, and ivec2 are conversion functions. They convert their parameters into respectively vec4, vec3, and vec2, vec3e. It's shortcut for vec Oh, I see. So vec3 is just shortcut for 3 e's, of course. But I think the pixel of an image must be done with the image store function. As explained in previous section, the content of the image is opaque and is always treated as floating points, even though we know that its memory contains integers. Okay, so the image store is function that is aware of its format, of the format of the image, right? So it's function aware of the format of the image. Okay. Calling this shader. Now that the shader is written, the rest should be straightforward. We start by creating an image as seen before. Let's just create that again. Here. We created that before. This time we cannot just clear the image like we did earlier. To actually pass the image to the GPU shader, we first need to create image view of it. Image view describes where and how the GPU should access or use the image. Here we want the view of the entire image, so the creation isn't very difficult. Oh, so we can specify sections of the image the GPU can see. Okay. So we just create default image view. Wrapper around image and make it available to shaders or frame buffers. Okay. Now, let's create a descriptor set by adding the image view, like we did earlier. Okay. Let's just do it. I should say necessary more than useful. Yeah, like it's necessary in the API, right? So we create a persistent descriptor set so we can actually pass the image. We can pass the image view into the shader. We have to create a descriptor for it as we did before. We went over that. Next we can create buffer for storing image output, of course. So we create another image. We create another buffer. We store the image in. So it will be transfer destination because we'll be copying into. It will be into host memory with a random access so it can be cached. I have no fucking idea what code I'm looking at here. It's a Vulkan API. Hi Tessa, did you get home safely? I hope you got home safely. And I hope you are hydrating. Oh my god, more cute emotes. Let's pin. Oh my god, did I pin it? I'm in the bath warming my bones. Oh, I hope the bath is good. I hope you will enjoy it. I hope you will enjoy it, Tessa. Now, the command buffer contains dispatch command followed by copy image to buffer, like we did previously. Nothing complicated. So we create a builder again with the same queue family. We build it. Now, we bind the pipeline compute. Right, which is like the shader. We load it, if I'm not wrong. Wait, where is it? Did I miss something? Yeah, here. Compute pipeline. Where did I define that? Oh, we defined that very far above, right? Okay. So we bind it, then we bind descript. Oh, there may be issue actually here. We may have to recreate a compute pipeline because can we reuse it? I mean, if it's used so far above, I think we may be able to reuse the compute pipeline. right? We may be able to reuse it. We will see the result. Bind descriptor sets. And where we dissecting Vulkan. I'm learning Vulkan because it's a graphics API, and I want to do graphics stuff for my stream overlay and for the future VTuber program. And I want to learn Vulkan for it because I think Vulkan is amazing thing. It's basically next generation of OpenGL, which is graphics API too, but a very old one. But Vulkan is like newer thingy from the same organization. Bind descriptor sets, we bind the compute pipeline, we say it is compute with a set 0 and with a set. We create it here with the persistent descriptor, and on the position we see the binding and set is 0, and we are cloning the image view in there. What do you want it to do? Render images and render 3D models, render stuff on the screen, show stuff on the screen. For example, images, text, I want it to show things like that. But I'm doing it very close to the hardware. I'm using API that's very close to the hardware. I know what they're for. Vulkan is incredible in compact and performance. It can squeeze out of things crazy. It is. But you have to know a lot about it. That's the thing. You have to know a lot about it to be able to squeeze the performance. Back in it, you just put images and stuff on OBS. Lol. But that's not... The thing is, in future, I want to have the... first, I have multiple reasons. First, I enjoy programming. Second, I want to just make my own stuff so I can be proud of it and use it proudly. Third is like, it's content. It's content. I can do just programming on stream of my own stuff. And yeah, it's just fun, I think. It's content for the stream. I want to learn it. And in future, I want to be able to have my, in future, I want to have like a 3D VTuber, right? And I want to, for example, be able to interact with the notifications, with the alerts. So someone maybe gives me follow, and I can with my hand punch the notification or grab it into my hand and show it, put it closer to the screen, and, have interactability. Well, I'm curious to see what do you do with it. I have plans. Obviously, it will take quite a time. She wants to commit violence against chat. I do. Or, when I get donate, I just grab the donate alert from the screen with my hand as the 3D model of my VTuber will grab the notification, and I will put it in front of my face or something, and thank you, and or I can maybe even pin it on the screen if I want. For example, if I will be in the mood, I will say, hey, let's keep you here for a while. I can pin the notification. For example, if I put it in some corner, it will automatically stay there permanently until I remove it or something, or for 20 minutes. So there is so many ideas. The thing is, I want interactability. I want to be able to interact with the notifications. I want it to be in one view, in one Vulkan surface, so I can have everything interact in some way. If I want to, I don't have to, but I want the option to be able to. So we are binding the data for the shader. We want it dispatched by this group. Yeah, perform single compute operation using compute pipeline. It's using group counts. I'm really excited to see what you do with it. Well, obviously, it won't be like tomorrow. It will take a lot of time. It will take a lot of time. And especially with the way I work on it, like... I was ignoring this stuff for months. I was procrastinating for months working on this. this is goddamn foreign if fuck to me. I never played with graphical or anything. Yeah, that's why I'm learning with viewers, right? So if in previous stream we basically went over 4 chapters. We showed how to initialize buffer creation, how to create compute pipeline, how to compute on the graphics card. Now we are working with the images a little bit. It's showing us examples and stuff. It showed us how to do command buffer, why they exist, and other things like this. It's all in the VOD. If you watch the whole VOD, it's all explained in there. Arisha doing violence that gives me the mental image of 4-year-old trying to punch something, only throwing themselves off balance, ending up hurting themselves in the process. That's very possible. She drew a yellow picture on her GPU. I did. Look at this. We drew this GPU. We drew this image on the GPU. We told the GPU to draw this, and we saved it in the image. This image was created by different device. It was created by different device that's connected through PCI bus. I think that's amazing. We basically told different CPU to draw this by just communicating through the PCI bus. I think that's an amazing thing. I mean, it looks simple right now, right? We just drew a rectangle. But I think it's amazing. I think it's really amazing. Like, what everything went into it, all the technical things, I think it's amazing. It's absolutely amazing. We drew yellow thingy on the GPU. That's amazing, isn't it? It's just different device. We told different device to draw it, and then we're going to draw a different thing too. And finally, just like in previous section, we execute command buffer and export the image file. And now we will have fractal thingy. Let's look at it. So we, of course, sync the thing again, so we get the results. Could you imagine someone drawing auto textures in a game like that, pixel by pixel? I mean, that's what's you can do it. And there are games what do this actually. They don't use actual created images, they create the textures with code. There is actually a lot of games like that. It's usually for experimenting, right? But it exists. And my nail broke. No. My nail broke. No. My nail broke. Oh. No. Damn it. Wow. That looks terrible. Oh, that looks terrible. No. My nail. Oh, it was the longest one. It was the longest nail I had and it broke. Wow. What happened? But yeah, we execute the command to copy image to buffer. We copy the calculated image in the buffer that we can see. Then we execute these commands. We wait for it to finish. Then we read the buffer content. We save it in the image. That's everything basically. Let's do it. Cargo run. Panicked. Error. Validation error occurred. Oh no. Oh. We have error. We have error. Oof. Validation error. Contains image view. Panic! No errors allowed. You valid as fucking shot. Wait, what happened? Caused by descriptor writes 0 elements? contains image view elements, but descriptor set binding 0 requires buffer. You know what happened? I love that it's called panic so much. Oh, panic! Panic! Run into bunker. But I think I know what happened. It's because we are reusing stuff. It's because we are reusing stuff. Right. Where is it? Right. Oh my god, this is such a spaghetti. This is such a spaghetti. Look at this. This is absolute spaghetti. Oh. Okay. Right. Right. Let's try to just comment it out. Let's comment it out. Huh. Oof. We didn't load the shader properly, I think. We didn't load the shader. I think. Right, there will be a lot of missing imports now. That's okay. Let's just import it. Boom. Okay, we are missing the compute pipeline. Okay, that's good to know. Set allocator. Rackety spaghetti. We have to clean it up because it's not assuming we are working with the same code, I guess. Let's just import things and let's figure out what we are missing for variables and fix that. Boom. Oh, RGBA2. Okay, boom. Right. We are missing compute pipeline, we are missing command buffer allocator. And descriptor set, okay. Command buffer allocator. Let's find it. It's here. Okay. This needs to be public. Good. This needs to be public. What else are we missing? Descriptor set allocator. This needs to be public too, of course. Let's save that because these are the allocators. These need to be like in the scope, right? We can reuse allocators. And now we are missing only the compute pipeline. We are just okay. Compute pipeline. Yeah, we are created here once. Okay. Now import the stuff, of course. We have to do. For that we need this. Right. Shader. And we have to load the different shader, right? We have to load the different one. We have to load the different one. Right. Okay, this code won't ever work again. This code won't work ever again, but whatever. Let's just make the new one work. Let's make the new one work. We have to load the fractal shader here, actually. Broken forever. Oh. No method layout, right. Import pipeline, boom. Now it should work. Now, run. Please work, please work, please work. It worked. Oh my god, it worked. Let's look at the image. 3, 2, 1. Oh my god, look at this. We drew this on the GPU. Excitement. Oh my god. We drew it on the GPU. We drew the fractals on the GPU. Oh my god. That's amazing. If we had actual window, we could make zoom and make it infinite scaling, right? If we had actual window and it wouldn't be just image. But this is amazing. This is made on the GPU. On different device, different CPU. Wow. We told from different CPU to different CPU to create this. And it was fast. Wow. Isn't that amazing? I think that's amazing. How many people are here? 8. Oh my god, there is 8 people. Good. You are suffering with me and having the same excitement too. Oh, it could essentially be infinite size. Yeah, fractals can be infinite. They have infinite. You can infinitely zoom into them. If in future we will be creating actual window, it won't be just image that we are saving. If it would be actual window, we could make infinite zoom into it, right? And it would infinitely, Claps, that's really amazing, Arisha. So proud of my dear girl. Oh, thank you. Very cool. This is amazing. It was made on the GPU. That's crazy. Won't that eventually crash the PC if you zoom in too far? It shouldn't. It shouldn't really. You can zoom into it infinitely and it's basically the same thing. Like, there is no issue. It will be okay. I mean, not infinite, because computers have limits, but basically infinite, okay? It would be basically infinite for humans. You would have to spend years and years scrolling in just to, But yeah, we could, for example, zoom on these small things and zoom, but because this image we cannot. Wow. This is so cool. Good. And I was able to figure out the code myself. We had errors, we had like mismatches, and I was able to figure out the stuff myself. Wonder how long it will take to crash PC with Fractal. You wouldn't crash the PC. You wouldn't crash it. Why would you crash the PC? You wouldn't crash the PC. The thing that could happen, the only thing I can think of that could happen is basically you could overflow integer when zooming in, and that's everything. It would otherwise be, it would just reset you to the first position. Unless you cannot, and it'll render a small section of what you can see. Yes, it renders on a little small section you can see, I think. Because it's infinite. Yeah. It only renders what you see, I think. It's like, The But we got this result. We got it. We finished chapter 5 and I'm still sad my nail broke off. Oh, my nail. Oh my god. My poor nail. Why do you do this to me? No, it looks horrible. Oh. Okay. So we are moving on to the graphics pipeline, chapter 6. We are moving on to the graphics pipeline. Whew, okay, we will be using fragment shaders and not compute this time. We'll be using fragment ones. Fragment shaders. So we will have to do something like this. Frag. And we will write here fragment and we will have the shader. Now we can commit it. So let's start. Oh, I'm still getting my nail. Why did it have to break? It was so pretty nail. Oh. Does anybody have glue? I want to glue it back. Let me hydrate before we begin another chapter. No, now I'm missing nail to make the sound. One of the nail that broke is the one I'm making the sound with. So now you are hearing only 2 bumps instead of 3. No. I have about 10 types of glue. Which do you want? Oh, that you can put on skin. Glue that you can put on skin. Please. Let me hydrate. Super glue it is. Oh my god. You know what? I think I will wait for it to grow again. Or I will buy fake nails. I will either buy fake nails or wait for it to grow. Okay, but thank you, Moonbeans. I appreciate it. I appreciate it. Graphics pipeline introduction. Up until now, we have created command buffers that perform 2 kinds of operations. Memory transfers, copying data between buffers and images, clearing image. Compute operations, dispatching a compute shader. Well, these 2 kinds of operations are sufficient in order to use the power of the GPU for parallel compute calculations as seen in the Mandelbrot example. There is 3rd kind of operations. I'm sorry, I burped. There is 3rd kind of operations. Graphical operations. Before they were used for general purpose calculations, GPUs were used for graphics, hence their name. To benefit from this, GPUs provide to developers a specialized, well-optimized series of steps called the graphics pipeline. Using the graphics pipeline is more restrictive than using compute operations, but it is also much faster. Ooh! It is much faster. There is nothing that the graphics pipeline can do that compute pipeline couldn't do. However, the graphics pipeline is much more specialized and therefore much more optimized. Some parts of the graphics pipeline are generally handled by dedicated chips on the hardware. Using the graphics pipeline can look complex if you haven't done any graphics programming before. Ooh, that's us. That's us. That's us. But it is essential to understand it if you want to render images in efficient way. Quick introduction. The purpose of the graphics pipeline is to draw a certain shape on an image. The shape can be as simple as single triangle or as complex as a mountain range. Draw a certain shape on an image. In order to start a graphical operation, an operation that uses the graphics pipeline, you will need the following elements. A graphics pipeline object that describes the way the GPU should behave, similar to the compute pipeline object that describes compute operation. One or multiple buffers containing the shape of the object we want to draw. A frame buffer object, which is a collection of images to write to. Just like compute pipelines, we can also pass descriptor sets and push constants, which we haven't covered yet. Push constants. Okay, I hope we will cover it. When you start a graphics operation, the GPU will start by executing a vertex shader that is part of the graphics pipeline object on each vertex of the shape that you want to draw. This first step will allow you to position the shape on the screen. Then the GPU finds out which pixels of the target image are covered by the shape and executes fragment shader, also part of graphics pipeline object. On each of these pixels, the shader is used to determine what is the color of the shape for the given pixel is. Finally, the GPU will merge this color with the color that already exists at this location. The graphics pipeline object contains a vertex shader, the fragment shader, plus various options that allows one further configure the behavior of the graphics card. This explanation only covers the fundamentals of graphics pipelines. Fundamentals. Graphic pipelines have tons of configurable options, plus additional optional shader stages. Ooh, oh no. There is so much more to learn, so much more than there is in this tutorial, right? There is so much more. Damn. I need to find some resource to learn it from. Oh no. These things we are doing are fundamentals. Does anyone have better resources to learn from these complex things, not just the fundamentals? The next sections will be dedicated to covering graphics pipeline in more details. In fundamental details. So, vertex input, which is the shape. Vertex buffer. The first part of drawing an object with a graphics pipeline is to wait! Why is there no music? Why didn't nobody tell me? Spotify died. Hello? Music? Hello? Oh my god. Spotify broke. Ignore this. Okay. Now we have music back. Oh my god, we are here. Okay. Wrong. Boom. So, now we can continue. Music is on. We can actually continue. I completely forgot that there is no music. Why nobody told me? Oh my god. 9 viewers and nobody told me the music went off. Vertex buffer. The first part of drawing an object with a graphics pipeline is to describe the shape of this object. When you think shape, you may think of squares, circles, etc. But in the graphics programming, the most common shapes that one will need to work with are triangles. I was focused. Well, good thing you are focused. I'm glad I was able to make you focus on the thing. Tessellation shaders and alternative primitive topology values unlock the possibility to use other polygons, but this is a more advanced topic. Okay. This maybe would be good to remember, to look up later. Maybe. Let's just plop it here. By the way, I have some resources here that we can look up at some point that I will need for the thing I'm working on. Each triangle is made out of 3 vertices, and the shape of an object is just a collection of vertices linked together to form triangles. For the purpose of this book, we are only going to draw a single triangle first. We are going to draw triangle. Oh, we are going to draw triangle. Okay. Vertices linked together. The first step to describe shape with Vulkan is to create struct named myVertex. The actual name doesn't matter, whose purpose is to describe the properties of a single vertex. Once this is done, the shape of our triangle is going to be buffer, whose content is array of 3 myVertex objects. Okay. That's interesting. Let's do it. Okay, let's look at it. So we import buffer contents. Oh, that's a macro. Right, we are importing buffer. So we are basically telling this structure can be buffer content. And we are saying the representation is supposed to be as the C ABI has, because Rust doesn't have stable ABI, which is, I can forget. I explained it in previous stream, but ABI programming is interface between two binary program modules. It's application binary interface. So Rust doesn't have stable binary interface, but C has. That's why we are saying use representation as the one that's C. We can use even different representations for different things, but we want this to be C representation. We say it has to be this format with macro for the buffer. We say it's vertex and it can be put in buffer contents. These are just simple macros to implement traits that just allow us to use the struct in the buffer for the type, so the types are satisfied. Otherwise, we would, because technically the data is just this, right? But we need the traits so we can actually use it with the types. So we can create our vertex with position inside f32, array q times float 32 bits. And first is red 32 bits, second is green 32 bits, and it's signed float. It's signed float, okay. Why is it red and green? I think we will figure that out. Let's continue. Maybe they will tell us, right? Here. Our struct contains a position field, which we will use to store the position of the vertex on the image we are drawing to. Meaning vectorial renderer, Vulkan doesn't use coordinates in pixels. Instead, it considers that the image has a width and a height of 2 units, -1 to 1, and that the origin is at the center of the image. Huh. Okay. Right, let's read it once more. we will use to store the position of the vertex on the image we are drawing to. Right, we are drawing onto a image. Okay. Being vector, that's... I feel like this wasn't this wasn't explained properly. Like, why we have to draw on the image? Why cannot we draw onto something else? Or, you know, it's like, it's not obvious to me. They didn't explain it, but it was obvious to them why we are drawing onto an image, which is like texture. Right, it's texture, and we draw on empty texture, I guess. I guess that makes sense, but I would assume there would be something like surface, or I don't know. Okay, let's maybe we'll figure it out later. Like previously, we found out the stuff later. Then maybe it will be in the windowing, chapter 7. Okay, mean vectorial render Vulkan doesn't use coordinates and pixels. Right. Instead it considers the image as width and height of the units -1 to 1 float. That the origin is at the center of the image. Okay, fine. So the bigger the image is, the less precision we have. Do I understand it correctly? The bigger the texture we are drawing on, the less precision we have. Isn't that weird? Isn't that weird? And do I understand it correctly? That seems counterintuitive. Yeah, I'm a little confused about this. You know, because like 32 bits has limited accuracy, right? 32 bits have a limited accuracy. I guess it's enough for 8K images, so it doesn't matter. I guess I will assume 32 bits is enough for even 8K images, 16K. So the 32 bits is enough for the accuracy we need. But what if the image is 5000K, right? Then it wouldn't work. The GPU wouldn't be accurate, no? I mean, I guess these GPUs are not supposed to draw on such a big textures, right? They probably cannot hold it even in memory. I'm assuming they cannot even hold it in memory. I guess it's just enough for our usage. I guess it's enough for our usage in real world. This accuracy, right? What do you think, Moonbeams? Is that set to its max ability, or are they limiting it? I don't know. Let's move on. Let's move on. So they are using float for coordinates, two floats for coordinates, and the smallest one is -1 and the biggest one is 1. When we give positions to Vulkan, we need to use its coordinate system. In this book, we are going to draw only single triangle for now. Let's pick shape for it, for example. Yeah, average triangle shape. Okay. The field that contains position is named position, but note that its name is arbitrary. We'll see below how to actually pass that position to GPU. Okay, so it can be named whatever. Okay, so we can basically create vertex from whatever structure, as long we have some data we want to actually use as vertex, right? So we can include it with other stuff. I'm assuming we can include it with other stuff that's not related to rendering. So we can, yeah. We can merge it with some other struct we are using for something else. Now, all we have to do is create a buffer that contains these three vertices. This buffer will be passed as parameter when we start doing the operation. Okay. Let's create a buffer. How do we do it? So, we use allocator, of course. Any buffer created for buffer usage is vertex buffer. Okay. What other we have usages? We have transfer, vertex buffer, index buffer, uniform storage, indirect, uniform texel. Texel? Huh. They said it's not used anymore, this word. I guess they still use it in here. Shader, device address, acceleration. Okay. So we are using vertex buffer. Memory type is on the device and we want to see it. We want the memory to be allocated on the device and we want to see it, and the vertices are here. Vertex 1, vertex 2, vertex 3. Right. Buffer that contains a collection of vertices is commonly named vertex buffer. Makes sense? Because we know the specific use of this buffer is for storing vertices. We specify the usage flag vertex buffer. Vertex buffers are not special in any way. The term vertex buffer indicates the way the programmer intends to use the buffer. It is not property of the buffer. Okay, so it's only for the programmer. That we are, the thing we are specifying here, the buffer usage, when we are saying vertex buffer, it's only for the programmer. It doesn't change how it behaves. Vertex shader. At the start of the drawing operation, the GPU is going to pick each element from the buffer one by one and call vertex shader on them. It is what the source code of vertex shader looks like. Okay, so this is vertex shader. Okay, let's copy this stuff. Let's go into shaders, create, actually, triangle vert, for example. Boom. And we need to actually put it here, so it will be vertex shader, and we will call it triangle, and it's called triangle vert. Boom. Nice. The line, so don't get an ego, vertex buffer. You're not special at all. Yes, hey, don't get an ego, you vertex buffer. You are not special. The line layout location 0 in vec position declares each vertex has attribute named position. Does it? That's a weird way to say it. At least from my understanding, this is a weird way to say it. Or declare. And of type vec2. This corresponds to the definition of my vertex trait we created. The vertex trait is used to describe the attributes of individual vertex that can be read by vertex shader. It provides methods for specifying the format of the vertex fields, which can be done using field attributes like format, name, when deriving the trait using vertex derive macro. Oh. The main function is called once for each vertex and sets the value of the GL position variable to vec4, whose first two components are position of the vertex. And sets the value of GL variable to whose vec4, whose first two components are position of the vertex. GL position is special magic global variable that exists only in context of vertex shader and whose value must be set to the position of vertex on the surface. This is how the GPU knows how to position our shape. I'm losing a little bit. I'm losing myself. Okay, so how does it... I mean, right. Wait, oh, okay. Because we are using the C representation. Because we are using the C representation, it is stable binary interface. So it actually can see, it has field position in it. That's why we call it position. So it's something that goes in. The something that goes in is vector position, and it is name of position. Still don't understand it completely. I don't like going away from things that I don't understand completely. Right. This corresponds to the definition of my vertex traffic rate. Okay, let's read this again. The vertex rate is used to describe the attributes of individual vertex that can be read by vertex shader. It provides methods for specifying the format of the vertex fields, which can be done using field attributes like format and name. When deriving the trait, using the vertex derive macro. Okay, so that's just saying us we can use this format macro thingy, and we use macro here. If we use the vertex macro here, we can use this one inside and define. Okay. The main function is called once for each vertex and sets the value of GL position variable to vec4 whose first two components are position of the vertex. GL position is special magical variable that exists only in context of the vertex shader and whose value must be set to the position of the vertex onto the surface. This is how the GPU knows how to position our shape. After the vertex shader has run on each vertex, the GPU knows where our shape is located on the screen. It then proceeds to call the fragment shader to draw the pixels actually. So first we have to define the shape, then we can actually fill the shape with color. So to create triangle and color it, we need vertex shader and then we need fragment shader. Let's continue. I'm not loading the shader yet. Oh, why are you skipping this stuff? I will have to do it again myself after, okay. Fair. After the okay, fragment shader. After the vertex shader is run on each vertex, the next step that the GPU performs is to determine which pixels of the target image are within the shape of the triangle. Only these pixels will be modified on the final image. More precisely, it is only if the center of pixel is within the triangle that the GPU considers that the whole pixel is inside. More precisely, it is only if the center of the pixel is within the triangle that the GPU considers that the whole... Okay. That's... Oh, I understand. So when center of the pixel is inside the triangle, it draws the pixel in. Okay. GPU then takes each of these pixels, one by one, the ones in the red in the image above, runs another type of shader, named fragment shader, which we also need to provide in order to start our draw operation. This is what example fragment shader looks like. I think we can use this one. I mean, it's an example, but yeah. Let's call it just frag. Or triangle frag. Type is fragment. Path will be this one. Shaders, triangle, frag. Like this. Of course, it doesn't exist now. But let's create it. Well, so long as majority includes the center. Yeah, exactly. So, triangle frag. Boom. So it will be red. The triangle will be red. Okay, that's okay. We don't need a rainbow triangle. I'm satisfied with this one. Wait, did I name it wrong? What did I name it? Triangle frag. That's correct, no? What is wrong? Triangle frag. What did I do? What did I do? Okay, it's fine. We just needed to reset because it's macro. The layout location out to vec4 fcolor line declares output named fcolor. Vulkan gives you the possibility to draw to multiple images at once. Really? Which is why we need to declare each output and its type. Okay. Drawing to multiple images at once is advanced topic that isn't covered here, okay? The main function is executed once for each pixel covered by the triangle and must write in fcolor. The value that we want to write to the target image. As explained in previous section, these values are normalized. In other words, the value 1.0 float will in reality write 255 in memory. In this example, since our target image contains colors, we write the color red. Fair. Yeah, we write the color red. Let's move on. I mean, we didn't load the shaders yet here. Should I load them or will they give us the code? Multiple images at once, I did not expect. Yeah, that's interesting too. What could you use that for? I'm sure there is some usage for it, but I'm sure it's very rare, no? I guess, or... Well, I cannot know. I'm not a graphics programmer. I'm just learning, right? I'm just learning. I'm big dummy. Right, render pass. Render passes. In order to fully optimize and parallelize command execution, we cannot just ask the GPU to draw shape whenever we want. Instead, we first have to enter special rendering mode by entering what is called a render pass. It is only once we have entered the render pass that you can draw. Well, you could draw the whole graphic at the same time rather than sequentially, so the whole thing would appear at once. No. Well, it will be always sequentially. You cannot do it not sequentially. Like, you have to send, I mean... They have to start sequentially. Because you send the command buffer, right? Command buffer can have multiple commands. So the GPU will start sequentially, but it can run on... The calculation itself can run on different CPUs, different cores, different threads. Right, different chips. I don't think you can draw it sequentially. You first need to get the vertex. After you do the vertex, you need to do the fragment after. You have passes, you have render passes. You cannot do it at once. You cannot do it at once. You have to do passes. You have to do first vertex, then fragment, then different shape, you know? You have to like layers. You have to layer it and have different priority for it, depending where you want the stuff. I'm thinking more like in video game, all the individual pieces that load in. Yeah, you can put them together into one command. Like you can put multiple shapes. You can put multiple shapes in one vertex pass, if I'm not wrong. Right. Yeah, that's more what I mean. Yeah, you definitely can do that. You definitely can do that. That's what people do for optimization. You take all the shapes on the screen, you put it into one vertex thingy, you use the GPU, the shader, to calculate it, then you have to again, for example, the textures, you put the textures into one big texture. So all the objects you have on screen, you get textures of all the objects, you put them into one like buffer, and it will be passed as one thing, right? But it will be used for multiple things, multiple shapes. It will, for optimization, of course, because you don't want to do more stuff. You want to do more at once if possible, for it to be optimized, because it's same as with instruction, right? SIMD is better than doing one instruction per data. You can do multiple data in one instruction, which is SIMD, which is single instruction multiple data. It's literally the name. SIMD stands simple. No, what? Single instruction, multiple data. Right. Which is kinda the same concept, if you think about it, kinda. Okay, render passes. Did we read this or not? In order to fully optimize and parallelize command execution, we cannot just ask the GPU to draw shape whenever we want. Instead, we first have to enter special rendering by the render pass, and only once we have entered render pass, we can draw. What is the render pass? The term render pass describes two things. It designates the rendering mode we have to enter before we can add drawing commands to the command buffer. And it also designates a kind of object that describes this rendering mode. It designates the rendering mode we have to enter before we can add drawing commands to command buffer. Okay. Entering the render pass, as in the rendering mode, requires passing a render pass object. Creating a render pass. For the moment, the only thing we want to do is draw some color to a single image. This is the most simple case possible, and we only need to provide two things to render pass: the format of the image and the fact that we don't use multi-sampling, which is anti-aliasing technique. More complex games can use render passes in very complex ways, with multiple subpasses and multiple attachments with various micro-optimizations. Vulkan's API is suitable for both the simple cases and the complex cases, which is why it may look complex at first, right? It's just very, yeah. Okay, what are we doing here? We call macro builds a render pass object whose template parameter is of indeterminate type. Single pass render pass. It's single pass, so it's only one time. We take a reference to the device, we have attachments. In attachments we have color, we have format of the color, which is this of the image. We have samples 1. Load operation clear. The content of the attachment will be filled by the implementation with a uniform value that you must provide when you start drawing. Okay, this is usually what you usually use at the start of frame in order to reset the content of the color, depth, and or stencil buffers. Store operation. The attachment will be stored. This is what you usually want. Well, this is the most intuitive option. It is also slower than don't care because it can take time to write the data back to memory. Pass color. Depth stencil nothing. Oh, okay, this is kinda complicated. Explain, please. Render pass is made of attachments and passes. Here we declare one attachment whose name is color. The name is arbitrary. Okay. So we are creating arbitrary attachments. We name them however we want. And one pass that will use color as its single output. Pass color. The load operation clear line indicates that we want the GPU to clear the image when we entering the render pass. Fill it with single color. While store op store indicates that we want the GPU to actually store the output of our draw commands to the image. It is possible to create temporary images whose content is only relevant inside of a render pass. Ooh, that's why there is the store op. In which case it is optimal to use don't care. Just don't care. Hey GPU, we don't care. We don't care. Instead of store op store. Entering the render pass. Render pass only describes the format and the way we load and store the image we are going to draw upon. It is enough to initialize all the objects we need. Blunt, very blunt. That's kind of weird. It's very blunt. Okay. Once more. Render pass only describes the format and the way we load and store image we are going to draw upon. It is enough to initialize all objects we need. But before we can draw, we also need to indicate the actual list of attachments. This is done by creating frame buffer. Creating frame buffer is typically done as part of a rendering process. It is not a bad idea to keep the frame buffer objects alive between frames. But I won't kill your performance to create a destroy few frame buffer objects during some frames. Okay, so we want to reuse frame buffers if possible. Reuse frame buffers if possible. Wait, what's wrong here? Oh, we are missing semicolon. Okay. Arguments are incorrect. Oh. Oh, I see. Let's hide all of this. View compute pipeline. Okay, like this. They have different name again. How did we call it here? Oh. We didn't create it. Okay, they want the new image view. Okay. How did we create image view above? Image view. Okay, but we needed this thing. We still need this one. Okay, now it's correct. Let's continue. Wait, what did we do? I didn't even look properly what we do. Okay, frame buffer new, render pass clone. We take a reference to the render pass. Frame buffer create info, vec view, which we pass. Oh, okay. We pass a vector of attachments, and first one is image view. Okay. I'm not perfectly understanding this. I guess because it's using some macro, right? It's using some macro and it's creating stuff that's not actually Rust, you know? This is not a Rust. This is some arbitrary definition thingy, and it's harder to see the relation between these types, right? So I'm having an issue between that. I guess it makes sense. First attachment is color. That's just name. In format this, which is the image, has this format. Sample, it is only one. We clear it and store it, and then we have pass here. And we are returning color from the pass. I want to know the relation between these names. Like, Do I actually need the attachment to be named color, to return color here, or, you know, I want to know this stuff. Explain. I want to know the relation between these names. If they have some relation, or I would have to experiment with that. We are now ready to enter drawing mode. This is done by calling the begin render pass function on the command buffer builder. This function takes as parameter the frame buffer, enum, and a vec that contains the colors to fill the attachment with. Since we have only one single attachment, this vec contains only one element. Clearing our attachment has exactly the same effect as clear color image function we covered previously, except that this time it is done by a rendering engine. The enum path as second parameter describes whether we are going to directly invoke draw commands or use secondary command buffer instead. Secondary command buffers are a more advanced topic. We were using only direct commands. We will leave it as inline. Okay, as a demonstration, let's just enter a render pass and leave it immediately after. Okay. So what are we doing? We create the command buffer. Okay, same as always. We begin a render pass. We provide the render pass begin info with a clear value. So what color we want, right? What color we want? We want blue. This is blue color, right? Let's clear with black color. This should be black color, right? And we will clear it with that. Render pass begin info. Okay, it just takes info from the frame buffer, of course. So we don't have to write it again. Subpass begin info in line. What kinds of commands will be recorded in the subpass? What else is there? Secondary command buffer or inline? Okay. They're not going to tell us about. They're not going to tell us about it. About secondary command buffers. Okay. We need more advanced book or something. I need to find some advanced book on Vulkan. And render pass with subpass and info default. What is that? What else is there? Oh, okay. So it's some struct. It's empty struct. Size 0. Okay, it's just to indicate the end. Okay. What do you accept, email? Subpass and info. Huh. Okay. I use for a feature. Well, future. Then maybe something else. The next section will introduce draw command, which will be inserted between begin render and end render. Okay. Okay. Putting it all together. In the vertex input section, we created buffer named vertex buffer, which contains the shape of our triangle, and wrote the source code of a vertex shader that positions vertices on the image. In the fragment shader section, we wrote the source code of a fragment shader that fills pixels with color. Finally, in the render pass section, we create a render pass and a frame buffer that contains the target image. It is now time to put everything together and perform the draw operation. You can find the full source code of this chapter here. Okay. Let's do it. Creating a graphics pipeline. Just like we had to create compute pipeline in order to perform compute operation, we have to create graphics pipeline before we perform a draw operation. This is done by first creating the shaders, just like for compute pipeline. I done this already. See? I'm in front of them. I just have to load them. Wait, no. I done that already. Have I? No, I haven't. I actually have to load them. No. Yes. Okay, let's load them. How was it called? Was it shaders? Yes. Okay, load. Which one is this? Vertex. Load. Oh, I didn't name it properly. Triangle. Okay, let's name it like this. Vert. Boom. Okay, and it's triangle vert. Good. And now shaders. Load. Triangle frag. Boom. We loaded the shaders. Nice. Then we can create a graphics pipeline. Oh my god. Okay. Look at this piece of code. Oh. Okay, second use, whatever. Oh. Okay. More on this later. They're skipping stuff. It's just half the things they're talking about. We will not talk about this. We will not explain this. More on this later. This is not going well. I understand it's hard. Maybe it's irrelevant, but damn it. More on this later. Okay. Thank you for the amazing comment. I love it. So, let's pipeline. A Vulkan shader can in theory contain multiple entry points, so we have to specify which one. Alright. Vertex input state. My vertex. No method definition found. We need to import straight, dummy. So they have it even wrong, okay. I guess it was updated and they didn't update the tutorial. Okay, we create vertex input state. My vertex per vertex returns information about this vertex type. Definition. Vertex shader info input interface. Unwrap stages. Okay, first, okay, we are creating stages. We create pipeline shader stage vertex and then fragment shader. And we have pipeline layout. We get the device clone, pipeline descriptor set layout, create info from stages, into pipeline create info device. Okay. Just boilerplate. Subpass from render pass clone 0. ID. It's ID 0. And we clone we get a reference to render pass. And graphics pipeline. Okay. We have to import a lot of stuff here. Okay. Multi-sample state. Okay. Let's look at it. So new graphics pipeline. Device, get the reference, cache. We don't have cache. We can have cache for pipeline. Okay. And the graphics pipeline create info. So we give them to stages. The stages of our pipeline. We have vertex fragment stages. Vertex input state describes the layout of the vertex input and how it should behave. Vertex input state. How did we get there? Okay. I don't understand this. I hope they explain it better. Indicate the type of the primitives. The default is list of triangles. Indicate the type of primitives. What do you have here? Primitive restart enable topology. Default. Set the fixed viewport. Yeah. We created viewport here. So I guess that's for the window, how we will see it. We set offset 0, 0. It will be window of 1024 on 1024 height and width, and the depth range will have from 0 to 1. Rasterization state default, multi-sample state default. Can we use some different multi-sample? New. What do you want? Create multi-sample state with multi-sampling disabled. What if I want to enable it? Can I enable it actually? I don't know how. Okay. Color blend state. Ignored. Look at this. The comment. Ignore these for now. Ignore it. Ignore. This later. We are not going to teach you this. Oof. Okay. This graphics pipeline object concerns the first pass of the render pass. Okay, subpass. We created subpass from the render pass. Okay, let's read it. When we draw, we have the possibility to draw only to specific rectangle of the screen called the viewport. The borders of the viewport will map to the -1 and 1 logical coordinates that we covered in the vertex input section of the book, yes, and a part of the shape that ends up outside of this rectangle will be discarded. We configured the pipeline so that we use one specific viewport, that the state of this viewport is fixed. It is possible to specify dynamic states when creating the pipeline, but since we left those at the default, which is empty, these are none. This makes it not possible to change the viewport for each draw command, but adds more performance, because we are drawing OpenGL, shader language, Rust Vulkan tutorial, random block with GSL syntax. I have few stuff. I have a little bit of stuff. That, yeah. It's a Vulkan tutorial, but someone ported the whole thing to Rust code and all. Really? Oh my god, I didn't find that, I think, before. Second. Let me check. Kyle Myers. Resources. Do I have Kyle Miles? No. Okay. Let's just add it here. Rust Vulkan tutorial, I guess. Like this. Boom. Thank you. That will be useful. That will be useful. Thank you so much. If anyone else has more resources, I want as much of them as possible, because I feel like that there is no complete resource for this stuff. It feels like I think we will lose the help, you know? We will have to figure out the stuff by ourselves, I feel like, at some point. Which is a little scary to experiment with this. Oof. But yeah, the render pass. Well, how did we do it? So builder, begin the render pass, right? Bind the pipeline graphics, bind vertex buffers, freeze the number of vertices, first the number of instances. Okay. 3 vertices, 1 time. Okay. The first parameter of the draw method is the number of vertices of our shape. All the other constants are in the case of drawing on multiple viewports or drawing multiple objects with instancing. We won't cover that here. I love how in every sentence they tell you about some feature and tell you, yeah, we won't tell you about that here. We won't tell you about that here. I love how they just, yeah, no, we are not telling you. I mean, I'm glad they put so much work in this, obviously. I'm glad for this tutorial. It's very useful. But it's funny, right? It's funny that every paragraph has, we won't cover this here. This is for later. We won't teach you this. This is really cool. But we are not gonna show you. Exactly. They're like, hey, this amazing thing exists, but I won't tell you about it. I won't show you. Okay. If you wanted to draw multiple objects, the most straightforward method is to call draw multiple time in a row. Once you have finished drawing, let's do the same thing on Malbert example and write the image to PNG. Do that as before. Let's first create a buffer. Okay. Let's create buffer. Transfer destination, of course, because we want the image into it, into system memory, then write the rest of the operations. Right. We have to put it above it, though. We have to put it above it. Like here. I have to... At least I know the order of things, you know? At least I know the order of things. At least that's something. Right. Come on, Buffalo, yeah, it's the same thing. We read it, we put it in the image and write it down. Okay, let's try it. Let's cargo run. Now let's see what image we get. Okay, we don't get an image. We don't get an image. Okay, render pass, use create info attachment 0, it's panic, run! It's color attachment, but it wasn't created with the image usage color attachment. Really? So they have different image usage. Okay. Wait. Which one? Which wasn't attachment 0? Attachment 0 is the image render view. It's the image render view. Yeah, view image. Where do we get the, where do we create the image? Here. Okay. Image usage. Image usage. Color attachment. Boom. Now you should work, right? Oh my god, it worked. Okay, let's look at the image. Let's look at the image. Everyone, pay attention. We created triangle. Let's look at it together. Oh my god, it's white. It's white. Oh my god, our first triangle. Oh, our first triangle. Can you believe it? Our triangle. Our own triangle. But as you can see, it doesn't have anti-aliasing. It doesn't have anti-aliasing. It doesn't have multi-sampling. Because I didn't know how to enable it. It didn't tell me because the tutorial said I'm supposed to ignore multi-sampling. So it's not actually smooth. But we have triangle. Oh my god. Clap, clap, clap. We have triangle and it's white. Let's make it black. Let's make it black. I don't think that's nice for you. If someone's in dark room or such, right? It's possible, but they won't teach you here. they won't teach me here. I wish I had someone who would teach me. You know, I have to always do everything myself. I have to teach everything myself, and I don't like that. I want someone to help. I mean, I like doing that, but I would like someone helping me, like someone actually teaching me, having a teacher or something. Okay. There is no simple control of it. Controls supporting between the samples. Okay, you know what? Let's attempt to do multi-sampling by ourselves, okay? Let's attempt to do anti-aliasing by ourselves. We will be big girl, and we will do it ourselves, right? We can do it, right? We can do it. We can do it. I believe in ourselves. Don't we? Don't we believe in ourselves? Right. I don't believe in myself. No breakpoint, thank you. Okay. Let's just press it in here. And let's see if it does something. And let's change the color. Where is the color? I can't find the color again. Where did the color went? Here. Let's make it black. Let's make it black. Boom. And let's check if it enabled. Oh my god, did it? No. It didn't. It's still. But wait, I didn't run it. I didn't run it. I didn't run it. The background was still. Oh my god, it crashed. It panicked. It panicked. Caused by multi-sample state, min-sample shading is some. Okay. You know what? I have an idea. Where is our owl? Owl. Owl. Where did you go? Return to us. Here. Okay. Controls where alpha of the fragment will be used in implementation defined. You know what? Let's do this. Let's do this. Doc Vulcano. Multi sample. Multi-sample state is actually what we use, yes. Okay. Sample count. Okay, we want to change sample. Oh, which one is it? Oh, images sample count. Okay, let's do sample count. What do you have? Let's use sample threaded hue. And let's remove this. Let's try again. Run. I will make no. The rasterization sample does not equal number of samples in the color depth stencil attachments of subpass. Okay. I don't think we will be able to do this. New method new deprecated. Okay. They don't tell you a lot of stuff. Okay. What does it say? Create info. Multi-sample state rasterization sample does not equal number of samples in the color depth stencil attachments of subpass. Doesn't it? Now. Where do you say? Input as. Do I have to do it here too? Rasterization. Topology. No, that's not it. That's not it. Rasterization state. Okay, new. What do we have here? Depth. Cool mode. Polygon mode. Rasterization mode. Okay, I don't think we will be able to do this. What's the render pass on for this 23? Wait, what? Line 23. At least it's black now. You have black background. It was above you. You mean this one? Subpass is made out of a render pass. And a render pass is made... Render pass is made here, which is single pass. Oh, samples! Oh, maybe. Let's try it. Oh, we want this one. Let's see. Does not... Attachments does not equal render pass attachment samples. Doesn't it? No. Do we have samples here? No such field. Okay. Samples. Then we send sample for the you. What are you complaining about? It's different. Samples of create info attachments does not equal render pass attachments. Create info attachments. Okay. Where are we creating create info? Okay. Not here. Frame buffer. Buffer. Stages. Subpass. ID. Right, we sent the view. Could be the view. Maybe. View. Do we have any samples? No. Okay. Single pass, render pass. Okay, let's single render. Single pass. Oh my god, the piano is going. What's going on? The piano is going crazy. Okay. That's not really helping, is it? Oh, that's not really helping, is it? Oh. Okay. I don't think we will be able to enable it now. We changed the samples. Yeah, it doesn't like even the samples. Okay. Oh. Very closer or further. None of these. Right, now it works. We can show triangle. Yeah. And here is what you should get. Yes, we did. And now chapter 7. How long are we live? 4 hours. I think we can continue. Windowing. So we will actually create a window to see it in. Windowing introduction. Up until now, we have only created applications that perform one quick action and then exit. What we are going to do next is create a window in order to draw graphics on it and keep our application running forever until the window is closed. Strictly speaking, creating a window handling events is not covered by Vulkan. Vulkan, however, is capable of rendering the windows. Things like that sampling are kind of the things I get in trouble for at work. I spend too much time obsessed on small things instead of moving on. I mean, multi-sampling is so important. No. I don't want things to look, creating a window. In order to create a window, we will use Winit. I have that. I encourage you to browse documentation of it. I actually used Winit before, because the projects that come with creating window are not part of Vulkan itself. The first thing that you will need to do is to enable all non-core extensions required to draw window. Surface required extensions automatically provides them for us. So the only thing left is to pass them onto the instance creation. Right, but like it won't be a requirement, and I'll be like, but I know I can make this work somehow. Yeah. Yeah, I feel you. Okay, so we have to enable extensions now, which is completely above here. Or completely on top here, somewhere here. Instance. Yeah, when we create instance, we have to do this. And the event loop, of course. Okay. Ignore this for now. Of course. Ignore this for now. As always. Don't worry about it. I can ignore it well. Oh, don't worry about me. Oh, da-da. Okay. Boom. Okay, now we require the extensions for the Vulkan to actually draw onto the window. Surface required extension, boom. Oh, what's wrong? trade bound. Okay, I think I used wrong imports, haven't I? I'm going to have PTSD over the words. Worry about this later. Don't worry about this now. I will too. I can't believe it. Like, ignore this for now. I did never explain it again. Ignore this for now. Like, I know what is this. It's just event loop. But like, ignore this for now. Oh boy. Oh boy. Oh boy. Minute. We are using minute. Boom. There's only one. $28. And we are using 29. Okay. Alright, we are using 28, we are using 29. Can we make it work? Can we make it work? I don't think. So this was correct, I should unwrap it. I did that right. I did that correctly, that I should unwrap it. Returns the instance extension of a correct surface from available to given event loop. But this event loop doesn't implement a draw display handle. Why don't you? Has display... Whose trait it is even? Has raw It's not yours. Okay. It's not yours. Doc Vulcano has raw. It's not. Whose trait it is? What the hell? Vulcanovin? Is it your trait? Creation error? No. It's a secret trait. We don't discuss where it came from. Oh my god. Let's check it out. Surface required extensions. Right. Where do you come from? Raw window handle. Okay. You come completely from something else. Use has displayed handle instead. Okay, so it's the Vulcano is outdated. Right. Okay. Let's try to use this. I just try to get the, I don't know, newer one. Alright. Cargo build. Yeah, I know I couldn't compile. It's okay. What do we have here? Where are you? I lost you. I lost you. Where are you? Here. Oh, what's wrong here now? I guess we have to downgrade the version we are using. Oh. That's kinda annoying. Right. Am I able to make the newer one work? What's the error? The trade bound minute event loop raw handle as a raw display handle is not satisfied. The following other types implement trade. The following other types implement trade. Raw window handle. Okay. Cargo Tomo, Vinet, 28. Celeste Vulkan streamer. Thank you. Let's just use older version then. Waiting on build directory, what are you doing? And hi XP! Welcome to the stream. Welcome to the stream. Waiting for file look. What a file look? Okay, no, it's running. Welcome to the stream. I hope you are having a good day. We are getting angry over this tutorial. It should work anyway. Event loop should implement it. Where are you? Vinet. Event loop. Let's look at this. Oh my god. Here. Do you implement Hesro? You do! Why doesn't it work? Because it's a different version of the library. It's just because of that. You could work, come on, you are source code, you are not compiled the library, you are source code, you can adapt to this, please. Don't be so annoying. Event loop builder new build? Okay. It does implement as a road display handle. It does. Oh. Ale great future. Okay, I think I can fix it. And use the newer version anyway. Oh, because we have big brain. Oh. Features. Come on, I cannot type. Oh my god. How was it called? RWH. Okay. Now, cargo build. We'll let you build up. You're confident. I love the piano. Isn't it nice? Does anyone else like the piano? I like the piano. Alright, and now. You will work. Right, you will now work. I have to wait for the LSP to initialize. Oh my god, it fucking works. It works! Oh my god, can you believe it? It worked. I like piano when I need to calm down. I think piano is appropriate for this. I need to calm down a lot after this. But this compass, I made it work with the newer version. Yay. You sound the opposite of calm. Oh, don't mention it, please. Don't mention it. We'll worry about that later. When you laugh, you sound like you're crying. Maybe I am. Who knows? Maybe I am crying. Right. No, I am not crying. I'm just laughing in despair. We need to wrap the window in an arc so that both you and Vulkan can keep reference to it. Next, we need to create surface which is cross-platform abstraction over the actual window object Vulkan use for rendering. Nice. After you made the change, running the program should now open window with the name below close when the main function exists. Let's try it. Run. Did anyone see the window? Right, it should open window, you say? Maybe it's too fast. Can we do sleep? You're not safe for work window, Arisha. What window? No, I don't have notes. No. Don't confuse me. It takes duration. I was confused for a while if I revealed something. Shake my head. Okay, let's do it like this. 3 seconds. Oh my god. Oh my god. Boom. Okay. Sure. Oh. That's annoying. Why are you working like this? No? Seconds and nanoseconds. Okay, let's do it like this. Oh my god. Wait, what's wrong? What duration did I use? Time duration. I don't want time duration. Where did you get here? Where did you get here? Oh my god, I don't want you. I don't want you. Bam 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 bam. Wait, what? STD. I want STD time. Which is 1. Boom. Let's try it now. Will we see the window if we give it time to open? I expect duration from duration. Sometimes I love parts of error messages. I mean, they are the same type, just from different module. So it didn't show the window. Okay. 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 Maybe it's changed between versions, you know? Maybe it changed between versions. It's okay, let's continue. Let's continue. Event handling. In order to make our application run for as long as the window is alive, we need to handle the Windows events. This is typically done after initialization right before the end of the main function using event looped object. Okay. Oh no, it all changed. So it's outdated. It's outdated. Okay. Where is this? How do I make it work? It's actually event and LVT. What is LVT? LVT. Right, LVT exit. Okay, they just changed it how the control flow works. Okay, exit. Nice. Let's move on. What this code does is block the main thread forever, cause the closure whenever the event loop which used to create our window receives an event. These events include the events that are tied to our window, such as mouse movements. When the user wants to close the window event close request event is received, which makes our closure set the control flow to control flow exit, which signals to Winit that we want to exit. Right now, all we are doing is creating a window and keeping our program alive for as long as the window isn't closed. The next session will show how to net show. It's called swap chain. Okay, but we are not actually creating the window. It doesn't show for me. Did it change somehow? We have to check it because it's a different version, and I want to use the newer one. That's how annoying I am. I do this for some reason. That should be default, really. But sure, let's do it. Maybe that was needed to show the window. Oh no, my stomach. I hope you didn't hear my tummy gremlin. Gremlin. Okay, it's not showing the window. Does anyone see the window? There is no window. Yormi can pick up the tummy grumbles. Okay, I'm glad. I'm glad. I'm glad I cannot pick up my tummy grumbles. That would be so embarrassing, actually. I would cry. I would cry if you would hear it. I'm serious. Let's run it again. With this event loop. I don't see the window! Okay. Do I have to somehow enable Wayland? Default Wayland. Okay. Let's try something else. Event loop. I'm gonna ignore you. Go away. We have to fix it. Okay. What do you have here? The user new. Okay, unwrap. What can we do to it? Right. Listen device set control flow primary monitor run exit. Right. Window builder. Maybe something is wrong in the window builder. Let's see. Let's see. With full screen. Maybe it doesn't have size. It doesn't have set size. That could be it, right? Maybe it doesn't have set size so we cannot see it. Maybe. Let's try. What do you want as min size? Into size. What is size? Just find size. DPI videos. What size? With min size. With how are they called? Window builder. Window builder. With inner size. What can you turn into size? Physical and logical. Okay. How do you create one? I see. You don't. Physical pixels. Logical size is what? Okay. Let's try it. Could just do full screen as test. I mean, I could. But I'm stubborn. Wait, okay, 400, boom. Okay, now, please, come up. Right. Full screen. It's using something weird again. Window builder. It probably wants monitor to put it. It wants monitor. Full screen video mode, monitor handle, right. No. Window level. Is there anything about Wayland? Wayland. With team. Using avatar is debug to a system preference. Oh, I thought it would just max it. This sounds like more of a hassle than quick test. Yeah. Wayland. It should work on Wayland. What's the issue? I used it before on Wayland. Only new than builder build event loop. The second method is to customize your window. Once window has been created, it will generate different events. You know what's weird? It doesn't exist at all. The close button was pressed stopping. Yeah. It never... You know what? Let's do this. DBGA. Boom. Let's see what it writes. Let's see what it writes in the chat, into terminal. New events. Wait cancelled. What is wait cancelled? How can you cancel wait? Oh, I know. Okay, so it works. Okay. Let's go up. What's the first event? I don't know what. Let's ignore this one. Event. Wait. Oh, it's not public. Wait, what? Window event. Oh, ooh. Okay. Window event. And we want it to be window event. Wait. Come on, wait. Where is wait? Where was it? New events. Wait cancelled. Cancel the wait command. New events. Whatever. Boom. What is a new events event? Emitted when new events are from the OS to be processed. Okay. Start cause enum wait cancelled. Okay. Now show me your thingy. Okay, new event init. Event resume window and window ID scale factor changed. New inner size weak. New event resized. Show me your thingy. Yes, show me your thingy. Physical size. It was resized. So where is the window? I don't see it. Am I blind? Is it here? No. It's not on second monitor. Okay. Let's continue. I guess. I mean, this is weird. Why doesn't it work? For your sanity's sake, I hope you don't find like 50 open windows somewhere. Oh my god. Ugh. Me too, bro. Doesn't look like it. Doesn't look like it. Am I doing something wrong? We create a window builder. We build it and unwrap it. It doesn't error out. Builds the window. Possible cause of error include denied permission, incomplete system, or lack of memory. It didn't error out. It didn't error out. It didn't. It didn't error out. Maximized. It's maximized. Oh my god, I hope it's not this. Silly girl. I hope it's not this. It was not. Well, it doesn't work still. Does it now? Active. Yes, it's active window. It's whatever. Transparent. Hey, false. It's not transparent. With title. Okay, can I do something like this? Okay, I can. What else can I add? So I don't know. Build. This is going to be the most specific window ever created. With enabled buttons. Do you want buttons? Does anyone want buttons? I don't want buttons. With a resizable. You know what? It's not resizable. I want it to be 400. You know what? Okay, what else? What else can I do? Window decorations. True, I want all of the window decorations. Right. Transparent, did I already say no? Well, blur. Window level, what's window? Okay, window level. Normal, always on top. Okay, always on top. Now. God, I swear. Okay, it's not working. It's not working. But apparently the window exists. It didn't fail. It created the window. The function didn't fail. So, what's wrong? What's with position? Okay, let's try position. What should be P in the position? What is position? Position. Minimum DPI, whatever. New boom position. What do you take? You take S into position. Really? Are you kidding me? To physical. Okay. Physical. It will be the same thing. Physical position. Okay. So it will be. It's getting really long. I don't think this will fix it, okay? I don't think this will fix it. It's not even happy about it. Can I just do this? No. Okay. Why is this angry? Expected I threaded you. Okay, it's I threaded you. It's not happy. Okay. Physical oh, this is size. Position. Okay, now. Wait, I said 400. I want position 0. 0 maybe? Okay. That obviously didn't work. Okay. Alright. Version 28. It was version 28. Zero 28. Right. Right. Did we add something else in there? We did this. So let's remove this one. Let's do cargo build again. Right, it's wrong. That's what we actually want. It's loaded. Oh my god, it's loaded here. Okay. So, now. Now we have to change it again. Now we have to change it again. You are without unwrap. You are without unwrap, baby. I'll just follow this thingy. Window creation. We do this, we do this. Yes. Yes, and now we actually want this one. Yeah, this is not Starto. That's okay. That's okay. If this works with the older version, I will be angry. I will be big angry. Right. Cargo... Wait. Cargo run. And let's see. If it opens window, I will scream. If it opens window, I will scream. Maybe. It did not even compile. Turning headphones down just in case. Hey, I'm not that loud. Yeah, there is no window. It didn't help at all. It didn't help to use the old version. God. my god. Bye. Bye me. Let's use the newer version because it doesn't work too, you know. It doesn't work too, so we are consistent. And let's just move on into the swap chains. Let's move to the swap chains, right? I have no idea why it doesn't work. No idea. At all. At all. Introduction to swap chains. Wait, didn't we miss anything? Absolutely not. Introduction to swap chains. Since we are going to draw to a window which is ultimately on the screen, things are a bit special. If you were going to write directly to the window's surface, you would introduce staring and other strange artifacts, because you would be updating an image that's already visible on the screen. To ensure that only complete images are shown, Vulkan uses what is called a swap chain. Swap chain is a group of one or two multiple images, sometimes two images, but most commonly three. If you have ever heard terms such as double buffering or triple buffering, it refers to having respectively two or three swap chain images. The idea behind swap chain is to draw to one of its images, while another one of these images is being shown on the screen. When we are done drawing, we ask the swap chain to show the image we have just drawn, and in return, the swap chain gives us drawing access to another of its images. Optional checking for swap chain support. Of course, our device definitely supports swap chain. Every device should support it, and if not, there is a way around it. Now, can we... Yeah, this is just checking for it, no? Or what are you doing here? Optional checking. Yeah, I don't want that. Updating logical device creation. Okay, we have to update actually the device creation. Physical device, maybe? No, it's with a Q, we need... Here, we need to update this. How? Oh, we enable the extensions for the device. Okay, we enable the extensions for the device. Let's compare it. Yeah, we just... Wait, what? Did we miss something from here? Okay, redo this. We have to create this. Boom. Nice. We enable the swap chains. Creating this swap chain. Swap chains have a lot of properties: the format and dimensions of the image, optional transformation, presentation mode, and so on. We have to specify a value for each of these parameters when we create swap chain. Therefore, we have to query the capabilities of the surface. Okay. That makes sense. We have to know what the capabilities are. That's completely logical. What's wrong? Did it change again? Expect the surface from the result. Ooh, okay. Where are we? Here, we have to unwrap it, okay. Let's unwrap capabilities. Of all of these properties, we only care about some of them, mainly the dimensions of the image, which have to be constraint between a minimum and maximum. The behavior when it comes to transparency, composite alpha, and the format of the images. Okay. So dimensions, window in the size. Composite caps, supported composite alpha, and return get the first one, of course. Image format, physical device, surface format, surface. Formats, unwrap, get the first one again. Okay, we're getting always the first. I will build thingy. Combining everything and create a swap chain. Let's create swap chain. We have to import it, of course. That's not nearly enough properties on the window. It's at least 10 more. I mean, it's still there. It's still there. I didn't remove it actually. Image format. Wait, what? What? Is that a result? What is the result again? It did unwrap. What are you complaining about? Option sum. Considering using X. What? Why do you have it in sum? Boom. Fixed. What do we do here? We get a device, we get a surface, we create swap chain, create info struct again, min image count, counts min image count plus 1. How many buffer to use in the swap chain? Minimum number of images to be present. Okay, plus 1. Image, so it's 1 plus 1. Image format, dimensions into, we get dimensions, we get color attachment, composite alpha. Okay. It's good to have min image count to be at least one more than the middle, to give it a bit more freedom to the image queue. For additional information, check the swap chain documentation. Other initialization. And now they all made it into functions. Now they put everything in the functions. Oh. Thank you. Let's yeah, I love that. What do you change? Where are you pushing the images and surface? I don't want to turn it into functions. No, not now. We are learning. I think it's confused what we are trying to do. We're trying to learn. Okay, let's just... For each... Oh... Get frame buffers. Oh, I see. Well, this is nice. If you feel lost in all the code, feel free to take a look at full source code here. Of course. Well, you made everything in the functions out of nowhere, so it's really hard to learn from because we just changed everything we did. If you realize that. You are here. Okay. Command buffers. Iter frame buffer build. Device swap chain. What do you do with swap chain? Okay, you get a render pass. Where do you put the swap chain in here? Format, image format. Oh, I see. We're replacing a thingy. Main events cleared. Event resized. Window resized. Oof. Viewport command buffers. Why did you put it everything in the functions at this point? Did you do it the whole time? No. Okay. What have you done then? Isn't this kind of weird? Like they're trying to teach us something and then, yeah, now you have to put everything into functions. Sorry, Right, isn't that kind of weird? That's kind of weird. I think. They should have done it from the beginning if they were going to. Exactly! Now I have this whole file, you know, trying to learn. And hey, now you have to put it into, no, put it here. How am I supposed to, like, orient in this now? Okay, obviously they are taking some images here. They are iterating image view, they are creating image view from every single one, they are creating buffer. So I think we need at least this function. We need at least this function, if I understand it right. Christ's sake. Christ's sake. And buffer, boom. Okay. And a render pass. Like, I'm so glad you agree with me that I'm not crazy, but like, in a render pass. Literal crazy girl. I mean, I am. I am crazy. I'm big crazy. They have surface. They have this stuff. They have this stuff. Queues next. Swap chain. That's completely okay. No issue here. Render pass. That's new. Okay, so they... Okay. What is the render pass function? You know what? Come here. Come here, baby. Come here, baby. We want to use you now. We want to use you. You do. Of course, import. Boom. Nice. And now to remove the code here. Nice. Thank you. Amazing. I'm so happy you made me do this. It's so useful you made me do this. It's definitely not completely useless and yeah. Very important for the part of me learning, right? Right. After you create swap chain, you want it. Right. Let's put away this render pass. And frame buffers. Do we have frame buffer? We have one. Okay. I think we will need to remove this one. At least. Where is swap chain? Swap. Hey there. Whatever, put it here. Okay. What else did you change? What else have you changed? Window inner size into. You changed the viewport. Okay, you changed the viewport. Window inner size into. Get pipeline. They also switched to version 27 for some reason. It switched the language to Perl. I wouldn't be surprised at this point. I mean, look at this. Get command buffers. What are you doing? You're iterating over the frame buffers. So I'm just supposed to copy all of this stuff, basically. Okay. So we are using their code now. Am I supposed to even build it myself at this point? I should just download. I should just download their file. No, it would be so much easier to just download the file. But wait, it's probably outdated. It's probably outdated. Of course, my vertex is not in scope because we declared it here. Christ. Why did they do it this way? It's like the worst thing you can do when someone's learning. No? Well. This is how serial killers are created? Oh. You know what? I think you may be right. I think you may be right. I think you may be very right. Oh my god. You know what? Right. It's using the old stuff? Right. Okay. Okay. Where do you use the old stuff? Event loop. Right. Let's find the event loop. Event loop. You must be unwrapped. At least we know that much. Right. How was it? LVT? Whatever. LVT. Exit. Boom. Boom. A new variant for main events cleared. They even renamed this event. Oh, okay. How would it be called now? Main events cleared. Okay. Let's just look into the docs of Winit. If it loads. Is the stream up? I hope the stream is up. Doc Winit. Boom. Oh yeah. Alright. Events cleared. They have something like this? No, okay. They've cleared named key. Clear. Doesn't even have idea what it's changed into. Window event. Redraw request. Resize. What is this stuff even? It's not a window event. Main events cleared. A user event. New events. Start calls. Init, poll, resume time will reach. That's definitely not it, I think. Main events cleared. What can it mean? What can it mean? Main events. What did you rename it to? You know what? Version. Give me version 28. Main events cleared. Emitted when all of the event loops input events have processed and reader processing is about to begin. So it's just a redraw. Just redrawing. It's this one. It's window event now. They changed it to be window event. Maybe. Queue redraw request event. Okay. Let's add this one, about to wait. I feel like that's important. Boom. Now, do you compile? Please tell me you compile. Oh, they won't have the shaders. Oh my god, the window opened. What the hell? The window opened. Oh my god. Oh my god. Oh my god. It opened! We have a triangle! And I just downloaded their file because they made it into functions and I don't know what they changed. It appeared. It appeared. Wait, what? Wait! Where does it get the shaders? Oh, they're inlined. They're inlined. Look at it. Yeah, they're inlined, of course. They inlined the stuff. Right. From the beginning, okay, the beginning of the tutorial was pretty good, okay, the beginning was good, but the longer we went for, the worse it got. And at the end, they just, fuck it, here is completely something else. It's terrifying. Who knows, they just give giant chunk of code without explaining. Like, what is this? For clarity, you made everything worse doing your clarity work. Move some of them to separate functions. You could have made it like... Yeah, this makes sense. Mean to get frame buffers. I understand that. That makes sense to put into function. Yeah, I understand this one function. I understand this one. We don't need anything else. We don't need to turn anything else into functions. Why me? You need to sleep, Arishat. I don't know if I can sleep after this. I don't know if I can sleep after this nightmare. Why did they do this? You could just move one function. You could just move one function to get frame buffers. This is not clarity. This is making everything worse. This is making everything worse. But the window opened. You know what's interesting? The window opened. Right. Why did it open? What did they do different? Did they do anything different that makes sense? Alright, I edited the stuff, but it works. Surface required instance enabled required extensions. Yes, we did that. We did even this. We created the surface. We created. Yeah, we did everything same. I must have done something wrong if it didn't open the window, right? Well, what have I done wrong? What have I done wrong if the window doesn't open? The code for the window is same. And I edited their version to use newer stuff. This is weird. Okay, so this is our stuff. This is our mess. Not these. From here. It begins. From here. This is our stuff. Right. Let's run our stuff. I don't think it will compile, yeah, because we didn't. Yeah. Let's frame buffers. I want to try to make work. I want to try to make our own version work. Right. I want to try to make it work. I'm kinda not happy. Alright, with it. Yeah, we have all these positions. They didn't use single one of these and it worked. And without it, it doesn't work for us. But yeah, frame buffer. Where is the error? Where is the error? Come on. What was it? Here. Alright. Warnings. No. Error. Boom. Frame buffer. What are they doing in there? They get command buffers because they're doing for more images, right? That makes sense. But with a render pass, did we need to do this in a function? It's completely useless to get a render pass. Okay, buffers. We have more buffers, then it means we have to run more of these command buffers. Okay, so we need multiple command buffers. Get frame buffers. I don't think we are making this. We are making this work today. Oh shit! Why did you put this? Why did you put this in the function? That's completely useless to put this in the function. It doesn't make it doesn't have logical purpose. It's just for your clarity that doesn't exist. Right. Right. Render pass. we removed our previous render pass, which is here. And we could definitely use it. We could definitely use it. Look at this. Swap chain, boom. And it's like image format, boom. Finished. And we don't have to use the get a render pass function or whatever. Right. Render pass. Here. Boom. Yes, we need to find the different render pass, put it below here, you know, this stuff. Nice. What's the error here? What's the error here? No. Right. The command buffers. So we actually need get frame buffers, we don't need get a render pass. No. Vertex buffer. Get pipeline. Do we need this? We don't need get pipeline. We don't need get pipeline. We don't need get pipeline. Get command buffers. Okay, this is function we actually may need. Actually, do we though? Do we? I know they try to make it like somehow put it in their own stuff, into their functions and such, but this is not good. I mean, you have something, you are learning, and they just go boom. You could do this without the functions and it wouldn't mess with it that much. We have get command buffers. Okay, we have get frame buffers and get command buffers. That's all we need. If I'm not wrong. We have our shaders here. We have our shaders here, nicely, in files. Retro request about weight, nice. We don't want. Do we? We don't. Do we? No. This is in the command buffer creation thingy. Isn't the command buffer? Right. I'm just now like trying to understand what they did with it, right? Dooby dabba dabba. What is that? Dooby dabba dabba. They have additional stuff about the resizing window that we don't need that. We don't need all that stuff. Resized, window resized, great. Window resized. Okay. Yeah, we have to recreate swap chain on every window resize. That makes sense. That's completely okay. Alright. Do they actually explain this stuff below? They are. Right. This didn't go as I planned, to be honest. This didn't go as I planned. We need books. We need some good sources to learn from. We need some good sources to learn from. That's, I think now I understand why the Ash library is used that much, because you can use normal Vulkan learning resources, because they just imported the stuff. Basically they just made they just wrapped it. and everything. They didn't change basically any stuff. It's all unsafe. It's all. That's why people prefer the Ash library. It doesn't have safe guarantees, right? But you can actually learn the Vulkan with this library and with C++ resources, right? I think that's why Ash is more popular, because there is not enough resources for Vulcano. What do you think, chat? What do you think? Is it possible? Maybe. I think that's the case. It's easier to learn Ash because they are using the same function names and stuff as the original C++ library. Could be if it's more supported. But I like the safety of Vulcano, right? I like the safety of Vulcano. I cannot deny that, but Vulcano needs more learning resources, I guess. Right. Vulcano needs more learning resources. You go away. What do you even return? You return command buffers. Hi Celine! How are you doing? I hope you are doing good. I hope you are having a good day. You belong in Tardieri. Oh, I belong in cute box. I mean, I wouldn't deny such a request. I wouldn't deny it. I would like some comfy, cozy box, you know. That would be very nice. My own box. I'm doing well, thanks. Oh, I'm so happy. How's the stream going? It went really well. And then the tutorial, then the thing we are following to learn Vulcano completely fell apart. It completely fell apart in last chapter. Yeah. They made a mess out of it. Oh, your own box, and here I was hoping to share. Oh, I mean, oh, oh, making me blush. I mean, I would like to share a cute box with you, Celine. I would like that. That's a bummer that they fell down at the finish line. Yeah, they fell down at the finish line. Yeah. I can try to fix it. I will have to push some plushies around to make room then. Oh, you will make room for me. Oh my god, that's so sweet. Thank you. Then I have to visit you. Then I will have to visit you. I love how they say for clarity. Okay, the code is more readable. Fair. The code is more readable. Okay, I acknowledge that. But it's terrible when you are doing stuff in some way and then boom, we are changing. We are doing useless functions that don't make anything. Don't do anything, right? For some reason you are passing a reference to swap chain. Reference by the way. It's like someone else wrote chapter 7. Yeah, it's almost like someone else wrote chapter 7. Like some different person. I mean, look at this. This is reference of reference. They are sending reference of reference into this function. That's fun. Get frame buffers. We have the shaders. Get pipeline. Do we actually need to edit the pipeline? No, we don't. We need to do anything about the pipeline. Get pipeline? No. Come on, buffer us. Yes. The initialization is finally complete. Next, we will start working on the eventual program the functionality of each frame. Right, that's what we are supposed to do basically now. Yeah, because we get the command buffers and that's everything we need. So we can actually put this away because that will be inside the window. That will be inside the window. Alright, that will be here. I mean, that can be anything. About the weight, we request a redraw. Oh, that's completely okay. Requested a resume. I know. Hop. So they add these two variables. Window resized, recreate swap chain. Okay. And that's good. That's good. That makes sense. Actually. For once. Let's import this. here. What did you do? You did this. I think they expect you to download the source code and just read it while analyzing or something. I want to follow it properly. But this is kind of... yeah, I know. More on this later. They still didn't. I mean, they did. Okay, I won't lie, they did tell us more about it. I'm just little, right, I'm not feeling it right now. Little angry. We'll get pipeline. Okay. What do we do next? Currently the viewport state is set to fixed scissor irrelevant. Well, you are somewhere else. Yeah. We are here. Which is here. Acquiring swap chain, acquiring next image, swap chain, clone, this thingy, reference to it, if it's okay, it's returned as image I, suboptimal and acquire feature, out of date, okay. Acquiring and presenting. To actually start drawing, the first thing I need to do is acquire image to draw. Yes, good. The acquire next image function returns the image index on which we are about to draw as well as future representing the moment when the GPU will access to that image. If no image is available, which happens if you submit draw commands too quickly, then the function will block and wait until that is. The second parameter is optional timeout. Sometimes the function may be suboptimal where the swap chain image will still work but may not get properly displayed if this happens. We will signal to recreate the swap chain. If suboptimal, recreate swap chain. That's fine. Boom. When does this happen though? Sometimes the function may be suboptimal. Where the swap chain image will still work but may not get properly displayed. If this happens, we will signal to recreate a swap chain. When could this happen? The next step is to create a future that will be submitted to the GPU, right? That's completely sensible. We have to actually send it to the GPU. Then swap chain present. Okay. So, what do? We just swap chain present, we get the queue and swap chain image index with the image index and a swap chain reference, and then we wait for it in Flash. Like we did in earlier chapters, we start by synchronizing. However, the command buffer cannot be executed immediately as it needs to wait for the image to actually become available. To that we join. Ooh, acquire future, I see. Yes. Oh, okay. However, the command buffer cannot be executed immediately as it needs to wait for the image to actually become available. Makes sense. To do that, we join with the other future and we got from acquire next image. The two presenting the moment where we have synchronized and actually acquired the said image, we can then instruct the GPU to execute our main command buffer as usual. We select it by using the image index. In the end, we need to present the image to the swap chain, telling it that we have finished drawing and the image is ready for display. Don't forget to advance and flash the future. We are now doing more than just executing command buffer, so let's do a bit of error handling. Fair. That's fair. Execution map error validated unwrap. Wrapper for arrow types of functions that can return validation errors. Okay, future wait. Okay, you wait for GPU to finish. Flash error. It's not declared. Flash error here. Why doesn't it tell me? Unresolved import. Aha. Is it still unresolved? Damn. Did they rename the flash error? Let's check it here. Did they rename the flash error? The code is actually different. The code here is different. They call it Vulkan error now, out of date. Okay, now it's called Vulkan error, I guess. Boom. But it's really different from what they showed in the tutorial itself. For now, we will just wait for the GPU to process all of its operations. Maybe they will change it again, who knows. Finally, your triangle is complete. Well, almost, as you probably don't want for the CPU to just wait every frame for the GPU without actually doing anything. You don't want for the CPU to if you execute your program now, you should see the window pop up with nice triangle which you can resize without crashing. Okay, frames in flight. Executing parallel to... okay. Okay, so this is the stuff we've seen in there. Okay, they added it. Okay, they added it. It's okay. But now it should work, apparently. What is the one error I have here? What is the one error I have here? Control flow. Okay. Minute. Boom. Now, there is another error. I'm sure I'm doing something unnecessary. Mute, right, it must be mute. We don't need this buffer because that was for the image. Right, this is move. Did they use actually move for the event loop? They did not. Consider removing the borrow. I think it's wrong again. So they changed it in the core but didn't update the tutorial. Yeah, they didn't update the tutorial. That happened multiple times at this point. So... yeah. That happened multiple times. Oh my god, I closed it. It doesn't have errors. Let's try to compile it. Will it open the window for this? I'm curious. Will it open the window? It opened the window. Okay. We can even see the mouse events here. Focused false. Cursor left. Nice. Well, we made it. Work. We made it work in our file. We made it work in our file. Okay. But now, I want it to be black, right? Boom. And now, run. That's interesting. Why didn't it open before? Because I didn't actually I feel like it had to draw something for it to be visible. I feel like it had to draw something for the window to actually be visible here. Right. Maybe because of the system I'm using. It's possible because of the system I'm using it needed that stuff. But yeah, it works. It works, our own thingy. Nice. Triangle. Oh my god, that took quite a while. And what is this? Clap. Thank you. Clap, 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 clap. We did it. Frames in flight, executing instruction in parallel to the GPU. Currently the CPU waits between frames for the GPU to finish, which is somewhat inefficient. What we are going to do now is implement the functionality of frames in flight, allowing the CPU to start processing new frames while the GPU is working on older ones. To do that, I mean, we can continue with that some other day, maybe. We can continue with that some other day. New streaming. Nice triangle. Who do we have? I mean, do we want to implement today even the frames in flight? Do we want to implement frames in flight? Who knows? Who knows? How do you do it? Previous future join... Fences. Do you have it in you? To be honest, it was a lot today. It was a lot of stuff today. I will be honest. Fences. Vector of option. References to fence signal future. I mean, it's not a lot of stuff. Let's do it. Oh my god. Oh. Let's do it. Arisha, I would like to see you take the time to digest what you learned today. Taking too much at once means you miss out on things. I know. I'm always after stream, I'm always returning and thinking about the stuff. But I understand it in the basics. It's just some stuff is very specific. You're welcome to do it if you're sure you want to, but there is no shame in letting your mind process what is there. I want to do it. It's okay. Thank you, Celine. You're very sweet. Oh my god, what have you done? I didn't copy the whole thing, did I? No. Alright, let's carry on. Okay. Frames in flight. Let's read about more after this. So we get, of course, the number of images we have, which is, if we check images, is how many slots in the buffer we have, how many slots in the swap chain we have, which is sensible, right? Which is sensible for once. And we need to import this. What's wrong? But it doesn't need to be mutable, I know. It will. Following times implement GPU future. Oh yeah, it will relies on... Yeah, let's just read it now. So, frames in flight. Executing instruction parallel to the GPU. Currently the CPU waits between frames for the GPU to finish, which is somewhat inefficient. What we're going to do now is to implement the functionality of frames in flight, allowing the CPU to start processing new frames while the GPU is working on older ones. To do that, we need to save the created fences and reuse them later. Each stored fence will correspond to a new frame that is being processed in advance. You can do it with only one fence. Check Vulkan's triangle example if you want to do something like that. However, here we will use multiple fences, likewise multiple frames in flight, which will make easier for you to implement any other synchronization technique you want. Because each fence belongs to a specific future, we will actually store the futures as we create them, which will automatically hold each of their specific resources. We won't need to synchronize each frame, as we can just join with the previous frames, as all of the operations should happen continuously anyway. Do we understand this? Because each fence belongs to a specific future. Right. We will actually store the futures as we create them. Yes, which will automatically hold each of their specific resources. We will need to synchronize each frame. Yes, that makes sense. Here we will use fence and future somewhat interchangeably, as each fence corresponds to a future and vice versa. Each time we mention a fence, think of it as future that incorporates a fence. Fair? In this example, we will for simplicity correspond each of our fences to one image, making us able to use all of the existing command buffers at the same time without worrying much about what resources are used in each future. If you want something different, the key is to make sure each future uses resources that are not already in use. This includes images and command buffers. That makes sense. Let's first create a vector that will store all of the fences. Frames in flight, we check how long how many frames images the swap chain has. We create vector with that. And previous fence I. Index. Previous fence index. Because the fence don't exist at the start or happen to stop existing because of an error, they are wrapped inside the option. Each future containing the fence has the information of the previous one. Each future containing the fence has of which the type is contained inside. We will also be storing them in atomically reference counted, which will automatically free them when all the references are dropped. Fair? At the end of your main loop, remove all the previous future logic. Each frame we will substitute. All the previous future at the end of your main loop. All of it? You want me to remove all of it? Close you honeys. Ooh, hi, welcome to the stream. Welcome to the stream. I hope you're having a good day, and I hope you will enjoy my stream. Are you from Iceland? I'm not from Iceland. I'm from Czech Republic, Czechia, in Central Europe, heart of Europe. But yeah, welcome to the stream. At the end of your main loop, remove all the previous future logic. Oh, thank you for the follow. Thank you so much. Welcome to my plushie collection. Oh, very Czech. Oh, thank you. Oh, we reached the follower goal. Oh my god. Yay! We reached the follower goal. We have 100 followers. You're my 100th follower close. Oh my god. Thank you so much. Thank you so much. Yay! Wait, where did I end reading? I bet you say that to all of your followers. I'm not. I swear. Look at this. Your followers goal of 100 was just completed this minute. It was you. Just kidding. I know. It was you. Thank you. So where did we end? At the end of your main loop, remove all the previous future logic, and of my main loop, remove future logic. Okay. Are you telling me to remove all of it? Future. Only future. So this stuff. You are telling me to remove this stuff. Oof. Okay. Each frame we will substitute the fence that corresponds to the image we have acquired. To make sure the new future and the old one will not be using the same image, we will wait for the old future to complete and free its resources. Okay. Let's put it into editor and check how it looks. Image fence. Wait for the fence related to this image to finish. Normally this would be the oldest fence that most likely has already finished. Okay, we take the image index, go into fences, and if it's some, we wait on it. Okay, that makes sense to me at least. Yeah, I cannot find suboptimal, I know. We have to remove it. We will join with the future from the previous frame so that we only need to synchronize if the future doesn't already exist. Wait, we will join with the future from previous frame. Understand, so that we only need to synchronize if the future doesn't already exist. Huh. Oh, I understand. Basically, if the previous doesn't exist, if the previous one doesn't exist, it means we just created the stuff, so we need to synchronize it for first time. Just this time we do it in different place than before. We will yeah. Here we call box to our futures to store them in a heap. As they can have different sizes, the now cleanup finished function will manually free all unused resources, which could still be there because of an error. Now that we have the previous future, we can join and create a new one as usual. Fair? That's basically same, that didn't change. We have the suboptimal thingy. Should I have removed it even? I feel like I shouldn't have removed it. I feel like I shouldn't have removed it. But you said everything related to future. It's your fault. Tutorial, it's your fault. And substitute the old obsolete fence and the error handling. Okay. Yeah, we just get the... Yeah, I see. You hop. We have to remove you, or no, what's going on? Boom. Image Yaaay. Yeah, we removed that stuff. No, wait, do we have it here? Let previous, let execution, frames in flight, here. Actually, I have it in my thingy still. In my wait, what? That's oh, that's okay. Can you stop showing this stuff? What are you warning me about? It's not. Oh my god. Okay, let's do this. Go away. I want to see actually. Okay. I don't need to remove this, even though we are acquiring the future here for the image, but they meant probably the fence. So when they said we can treat future as fence, and vice versa, they were wrong, I guess. Nice. Usage of arc doesn't send or sync. That's fine. We need us to actually deallocate the stuff because it's in a heap, and when there is no more references, it deallocates. Oh my god, hi. Press face, current face. Nice. In the end, we finally achieved fully working triangle. The next step is to start moving it and changing its properties. But that's something for the next chapter. If you have any problems, take a look at through source code. Next chapter, coming soon. Oof. So we actually finished this stuff. And these are people who made it. I'm grateful for it, obviously. I'm grateful. It was amazing introduction, actually. There were some missing things, some stuff that wasn't explained, or like, why do you have to do this? That's usually the most important in this stuff. Why do you have to do this? I know you are telling me to do this because it does this, but why do we need the thing to do this? That was missing sometimes. But otherwise it was great. The ending, how it was all moved into functions, wasn't... I feel like there should be more graceful transition, right? There should be more graceful transition. Just worry about that later. Well, I just think there should be like graceful transition, because they just shoot at you these big functions when you all made it currently into like stuff, when you follow the whole tutorial and you have mess in the code. It's the documentation open source. It is. You can definitely, if you feel you are missing from this list, feel free to add yourself in PR and that's that. But you can change it, definitely. It's open source project, right? I feel like some graceful introduction of the functions would be better than just slapping it in your face out of nowhere. Hey, do this. But you followed all of the tutorial, right? So you have the stuff filled here. You didn't delete it. You didn't tell us to delete some things, right? You just... There were just missing parts. It feels like nobody actually tried to follow it, right? It feels like nobody actually tried to follow the tutorial themselves when they were making it. They just made it and thought, hey, that seems good. But they didn't try it, which is kinda not good. But I'm grateful. It was a lot of good information, actually. For like beginning of learning this Vulkan API, it was actually good, right? I mean, if you're making the tutorial, you probably understand it already. Yeah, but like, you should follow it, because they made you write a lot of stuff. A lot of different stuff that are even combined, and then you have to actually delete some of it. You have to comment some of it. You have to actually change some names of it, because some variables, for example, from chapter 3 or from chapter 4 into chapter 6 change names, and you cannot actually use it, so it like breaks your stuff, your consistency, and yeah, the previous code just won't work with this stuff, and they didn't tell you about that. They're supposed to clean it up or something, or it's yeah. I was just going chapter after chapter, and it wasn't that great experience. It wasn't good experience. The information was good, but the transitions from different code snippets and such were issue and naming consistency sometimes, and yeah. I could maybe make PR to fix some of it. Right. Maybe it would be good if I've written it all down into like Notepad or something. But yeah, let's run it. Let's hope it works. It works. We are a rendering triangle on my GPU. That's fair statement. I would say definitely the PR. I think the project is worth having. I think it was good. I will definitely check different resources and decide if I want to contribute into it, right? Maybe there is already some better resource. I don't know. This is their official stuff, right? This is made from the Vulkan library I'm using. This is made from them. Yeah. I guess it would be good to improve it, because it's first place people probably go to learn it, right? The people who choose Vulcano probably go here as first thing and try to learn it as me. So I think it would be good if maybe I make PR and fix some of the stuff. Yeah. But we are rendering the stuff, we have frames in flight even, so it's super smooth as you can see. It's super smooth when resizing. Nice. Nice. It works. We made it. We made it. We made it. Oh my god, we have a triangle. Can you believe it? We have a triangle. Nice. You can see messages when I press keys. You can see messages. This is HAY. Hey. But yeah, that's it. We learned the fundamentals in 2 streams. Or how was it? 3? I think 3 or 2. True, I think 2. We learned the fundamentals of Vulkan in 2 streams. I definitely have to look way more at the shader language. I have to learn more about it. I have to definitely learn more about the shader languages, about GLSL exactly. About the layouts, I want to learn more about the layout keyword. And yeah, some of the stuff they didn't tell us about here, like the tessellation shaders, the secondary command buffers, yeah. And for example, drawing on multiple images from shader and such that they mentioned. I'm sure there is a lot of more stuff. I have prepared other resources to try here. I have a lot of Vulkan tutorials links that we will go over, I think. Go over basically yeah, over the tutorials, the documentation, and I definitely need to find more info about the GLSL shader language to learn more. But yeah, tessellation shaders, alternative primitive technology, other than polygons, possibility to use other polygons. But this is more advanced topic, as they said. I made comment here like this. But yeah, I think that will be for today. We have working triangle. I think that's amazing. I think that's pretty amazing. Won't lie. Telling GPU to do something through PCI bus. Telling from CPU to CPU instructions for the other CPU to do something and sharing data. I think that's amazing. I think it's really amazing. I love it. I love it. Oh, look at this. We have triangle. I think I won in life. I think I won in life. We should rate someone. We should maybe rate someone. As we are finished. Let me check Twitch. Who do we have here? What are you laughing at? What are you laughing at? Oh. A Mizu, hot guy. Do you want help finding target? I won in life. Yeah, I won in life. I have triangle. I basically won in life. Do you want help find? I don't think I do. I think I know who we will raid actually. First, I want to thank every one of you for coming to my stream, especially because it's programming. Thank you so much. We reached 100 followers today. We reached the goal. I should maybe set a different goal. Manage goals. Was fun stream, Marisha. Oh, I'm so happy. I hope I could make at least one of you smile a little bit. I hope you could learn something from this stream. I have triangle. I basically won at life. Well, I will remember to give you triangle next time you need win. Congratulations, Arisha. Very proud of you, Kitty. What are you going to do for the goal? Let's start new goal. Oh, I don't know. I have no idea. Let's change it to 150 maybe, and just start it. I have no idea. Let's just start it. Boom. 150 goal is up. Maria, thank you so much, every one of you, for coming here. Even if you were not here the whole stream, just dropping by, I really appreciate it. It was so nice to talk with all of you in the chat. I hope every one of you have amazing rest of the day. And yeah. Wait, did Mizu just end? Did Mizu just end? It doesn't look like it. I think she is ending. Oh no, I think she's ending. Let's ask. Should we ask her? Oh my god. Let's check. Are you ending? Let's ask her. You wouldn't probably hear the audio. Asking is always a good idea, yeah. She's ending! I'm ending too! I don't do you rate someone together. Wait, do you rate someone together? Yeah, let's do the dual rate. Oh my god. Let's do dual rate. You cannot hear the audio, right? I don't know. Can you hear it? No, you cannot hear the audio. Oh my god, I'm so sorry. I'm being silent here, dummy. Oh. Can I make you hear it? You will hear me twice now and everything.
But never has any viewers. Well, heck, if my girlfriend is recommending them, then...
I can only hear it on my personal stream. Not that I was looking at hers while watching yours.
Okay.
You'll hear me twice now.
I have to change that. Okay. Dress pie. I'm gonna wait for the current ad to run out, and then we'll go off.
Dress pie. Okay, let's read the dress pie.
Freaking ads.
Let's prepare it.
They somehow always run when I'm about to end, and I'm never quick enough to like pause them at the end of the stream.
Let's just turn it on. Okay, I'm here. I opened the stream.
Laying me up.
You hear the music twice, I think.
Not on your mods can, but I do.
Let's start the raid.
I should really do that.
So it actually collects the people.
Subs, so
Thank you so much for all staying here while we are getting this ready.
Let me turn it on now. Where is that? Where is that option? Where
Let's
is
look
it?
at our amazing triangle. Well, right, I cannot
Ready? Hang on.
ignore that.
Ostat, I think. No, can't. Nope. Community roles manager? No.
But yeah, I thank you every one of
Moderation.
you for being here. I know this was a long stream, maybe frustrating, but I think we learned a lot of stuff and I'm proud of it. I'm proud of it and happy.
Subscribe, moderation tools.
Mm.
No, is it on the ad thing itself?
I'm very happy with what we did
Ads.
today. I mean, it's just amazing having something else GPU render this. So what is she doing? We're running out of
No,
time.
there's an option to let you see the notifications that the ads are running, but
Oh, she's
I mean, I should probably turn
delayed.
it on so you can also see when the ads are running. I don't know if that means you can pause them. I don't know where the option is. I'll look around. I'll look around for it at some other time. Okay.
I have to cancel it.
Oh,
Oh my
wait, am I
god.
think? Oh, okay, good.
She's always
You'll be raiding?
distracted.
Okay, we're going for dress pie. So, I'm ready. I'm ready to raid them. Are
What happened?
you ready now?
Oh my god, this is disaster.
That's
We should-
great.
She's always distracted. Can you believe it?
Right, I'm ready to raid. Let's just press the button. I'm pressing the button. Button's being pressed. Wow. Okay. I will be back tomorrow.
Yeah, I will be back on Friday,
We'll be
or
back
maybe
tomorrow.
sooner, depending how I feel. We're raiding.
I don't know what we're playing tomorrow.
Bye. Thank you everyone
Because we
for
finished
coming here.
Remnant 2
Bye bye.
today.
I hope you have a rest.
And
I hope an amazing rest
don't
of
know
the
what
day.
else we have.
Bye.
I'll find something. I'll find something we can play.